This is the number 3,546,281. To show this more clearly, we can put this number into a place value table. Our place value table looks like this. Here we have the units, tens, hundreds, thousands. Now a lot of people think millions comes next, but actually it's 10,000s, 100,000s, and then 1,000 thousands, and that's what we actually call a million. You'll notice that every time you go one place to the left, you're multiplying by 10 every time. Now let's put this number into this place value table. This helps us see the value of each of the digits. For example, the 2 here is in the hundreds column, so it's actually 200. The 3 here is in the millions column, so it's actually 3 million. Here's a typical exam question. It wants me to write down the value of the 6 in the number that I've got in the place value table. I can see that the 6 is in the thousands column, so the value of it must be 6,000. Now here's one of those for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. A typical exam question might be to write a number like this in figures. To do this, I always like to remember what 1 million actually looks like. Remember, in the place value table, 1 million looks like this. So 1 million is 1,000 thousands. So 500,000 will be 500 thousands, because 500 is half of 1,000. Now try these two yourself. Press pause and have a go. When you're ready, press play. You should have worked out that 1/4 is 250,000 and 3/4 is 750,000. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now what if we have a decimal number like this one here? We can actually extend our place value table to go past the decimal point. We know that if we move one place to the right, we divide by 10. That can be seen here in our hundreds, tens, and units. So if we continue this pattern of dividing by 10, we get tenths, hundredths, and thousandths. So our place value table now has numbers before the decimal point and after the decimal point as well. Some people like to write tenths as a fraction like this, and similarly for hundredths and thousandths. Now let's put this number into the place value table. It looks like this, and that helps us to see the value of each digit. For example, the 1 here is 1,000th. So now I'm being asked to write down the value of the 4 in this number, which is this number in the place value table. I can see that it's 4 hundredths, so I can write it either as 0.04 using this, or as 4 hundredths as a fraction like this. Here's one for you to try now. Press pause and have a go. When you're ready, press play. Here's the answer. Here's a typical exam question for you now. You need to choose your answer from one of these. Press pause and have a go. When you're ready, press play. Here's the answer. Because the 4 is in the tenths column, we know that the value of it must be 4/10. I'm being asked to put these numbers in order, starting with the smallest. To do this, I can use a number line to help me. So I just draw myself a quick number line here. Now what I'm going to do is circle each of these numbers on the number line. Once I've done this, it's really easy to see the correct order for the numbers. -10 is the furthest left, so that's the smallest. Then we've got -6, then -4, then 2, and finally 5. So this is the numbers written in order from smallest to largest. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In this question, I want to put these amounts of money in order, starting with the smallest. To help me do this, the first thing I'm going to do is line the amounts of money up. Now, I start looking at the digits from the left, so I'm going to start with the pounds. I've got £1, £1, no pounds, no pounds, and £2. So because these both had no pounds, I know that one of these two will definitely be the smallest. If I look at the 10 pences now, here I've got 20 pence, and here I've got 40 pence. So this one must be smaller than this one. So this is the first number in the list. And then this one. Now to find the next number, I go back to the pounds again. I've got £1, £1, or £2. So because these two have both got £1, I know that these two are going to come next. Again, I go to the 10 pences column. I've got 20 pence here and 0 pence here. So this one's the next largest. And then this one. Now I've only got one number left in my list now, so this must be the biggest. So these are the amounts of money written in order from smallest to largest. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. I want to find out which of these two numbers here is the biggest. One way to do this is to write the two numbers out. So I've got 0.09, and I also want to write 0.1. I need to line it up carefully with this one. So I line up the point, put the 0 here, and the 1 here. Now to be able to compare them, I really want them both to have the same number of digits. So in this gap here, I'm going to put a 0. Now if I start from the left, I can see they both start with a 0, and then the next digit for this one is a 0, but for this one it's a 1. 0 is smaller than 1, so this is the smaller number, and this is the larger one. So the answer to the question, which number is bigger, is 0.1. Another nice way of comparing them is to imagine that they're both amounts of money. This would be 9 pence, and this would be 10 pence. Clearly, it's easy to see that this one is bigger. Now here's a more typical looking exam style question. I want to do the same thing with these, put them in order. I'm going to start by lining them up. Notice how I've lined up the decimal points. Now I want each of them to have the same number of digits, so in any gaps like here, I'm going to add zeros. So starting from the left again, we can see we've got lots of zeros and then a 1. So one of the ones that starts with a 0 must be the smallest. Looking at the next digit, I can see I've got a 5, a 0, or 6s. So the 0 one must be the smallest number overall. So we start with 0.067. Now the one with a 5 in this position as opposed to the 6s must be the next one. Notice that I write 0.56 because I added that green 0 myself. It wasn't part of the original question. Now I've got to deal with the 3 that all start with 0.6. I look at the next digit, I can see I've got a 0, a 5 or a 0. So the 2 with zeros must come next. This one then has a 0 on the end compared to a 5. So this is the next one. Remember it's 0.6 because I added the zeros myself. And then this one, 0.605. This one is bound to come next. And then the only number that didn't start with a 0 is the last one. So this is the list of numbers sorted into order. Here are some for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I want to say what number this arrow is pointing to on this number line. To do this, I can see that I've got 10 equal sections on the number line, and the difference between 20 and 30 is 10. So if I split that 10 into the 10 equal sections, I get 1. So this must be going up in ones. To help me answer the question, I put these labels on the number line. Once I've done this, it's quick to see that the arrow is pointing to the number 22. In a similar way on this one, again I can see that I've got 10 equal sections. The difference between 6 and 7 is 1, so I've got 1 split into 10 equal sections. That's 0.1, so this one must be going up in 0.1s. That gives me this, and I can now see that the number the arrow is pointing to is 6.8. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. These slightly more difficult questions I answer in the same way. I can see that I've got 10 equal sections. 300 take away 200 is 100, and 100 divided into the 10 equal sections is 10. So this one must be going up in tens. Now I can see that the arrow is pointing to the number 290. For this one, again there's 10 equal sections, and 1,000 take away 0 is 1,000. So 1,000 divided by 10 is 100. So this one must be going up in hundreds. Now this one is slightly different because the arrow is pointing in between two numbers. We can see that it's in the middle of 100 and 200. So the answer is going to be 150. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. You need to know the meaning of all of these mathematical symbols here. Now, everybody knows this symbol, and it means is equal to. It came about because these two lines are both exactly the same length, so they're equal to each other. An example of using this would be 2 plus 3 equals 5. Now this one, which is like an equal sign that's been crossed out, means is not equal to. An example of this would be that 2 plus 3 is not equal to 6. Now reading from left to right, this one here is the less than symbol. An example of this would be here, 2 is less than 3. The way to remember which way round it is to think about here, that's a small height, and here, that's a bigger height. So the small number goes here and the bigger number goes here. Again, reading from left to right, this one's the more than symbol. An example using this would be 3 is more than 2. Again, notice that this is the big height and this is the small height. So the big number goes this side. Now this one here is a combination of the less than symbol and the equal to symbol. We've got the less than and the line from the equals underneath. It means is less than or equal to. For example, imagine a playground where you're only allowed in if you're aged 11 or under, so it says the maximum age is 11. That means that the age to be in the playground is less than or equal to 11. And finally, in the same way, this is the more than or equal to sign. So imagine going to see a film at the cinema and the rating is 18. This means that your age has got to be more than or equal to 18 to be allowed into that film. Here are some questions for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you. Make sure you read this one carefully. Press pause and have a go. When you're ready, press play. Here's the answer. If you need to be at least 1.4 metres tall to ride the roller coaster, that means you can ride it if you're 1.4 metres tall or anything above that. So your height needs to be greater than or equal to 1.4 metres. When we're measuring time, we can do it using either the 12-hour clock or the 24-hour clock. When we're using the 12-hour clock, we have times in AM and PM. AM is the time from 12 midnight to 12 noon. We sometimes think of it as in the morning. And PM is the time from 12 noon to 12 midnight, and that's the afternoon times. If we want to change times in the 12-hour clock to the 24-hour clock, we need to add 12 to the time if it's a PM time. Now 4 AM you can see is an AM time, so writing this in the 24-hour clock, it just stays the same, but we have a 0 at the start. So 4 AM written in 24-hour clock is 0400. 6 PM is a PM time, so we need to add 12 onto the 6. 6 add 12 is 18, so we write this as 1800. If I want to go the other way and change 24-hour clock times to 12-hour clock times, all I need to remember is that if it's less than 12, it basically stays the same, but gets an AM. So this time here is 2 AM. If it's over 12, I need to take 12 off it, and then it is a PM. So 15 take away 12 is 3, so that's 3 PM. Just to check this one, if I use this clock face here, this is 12, 1 would be 13, 2 would be 14, and 3 would be 15. So 1500 hours would be 3 PM. Here are some questions for you to try. You need to change all of these times to the 24-hour clock. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here are some more questions for you to try. This time you need to change the times to the 12-hour clock. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. We're now going to look at performing calculations using time. I'm being asked to calculate the difference in hours and minutes between the following two times. You might want to do this in real life to work out how long a film is on TV or to work out how long a journey will take you. The time I'm starting at is 10:35. The next whole hour on from this will be 1100 hours. The time I'm looking for is 1510, so I'm now going to go to 1500 hours and then to 1510. Now I need to work out the amounts of time in between these. From 10:35 to 1100 is 25 minutes. From 1100 to 1500 is 4 hours. And from 1500 to 1510 is 10 minutes. To find the total time, I've got to add these up. Adding the minutes together, I get 35 minutes, and I've got 4 hours here. So the total time is 4 hours and 35 minutes. For this second one, I can see that the times are in the 12-hour clock. It will be easier to work out if they're in the 24-hour clock, so I'm just going to change them. That one's 03:30, and this one's PM, so it's 14:25. So if I start at 03:30, the next whole hour will be 0400. Then from here, I'm going to want to go to 1400, and then to 14:25. So this is 30 minutes, this is 10 hours, and this is 25 minutes. Adding the minutes together, I've got 55, so I've got 10 hours and 55 minutes. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In this question, I'm given part of a train timetable. I can see that there are 1, 2, 3, 4, 5 different trains, and they stop at these places. Sarah's got to catch a train at Macclesfield, and she wants to get to Stafford before 7:30. The first thing I'm asked is what's the time of the latest train she can catch from Macclesfield. Remember, she wants to get to Stafford before 7:30. If she catches this train here, she's not going to get there on time. Nor for this one here. This one doesn't even stop at Stafford, that's why that's blank. So she's going to have to catch this one here. So the time of the train she needs to catch is 5:39. For part B, I want to work out how long the journey should take. What I've really got to do is work out the difference in time from 5:39 to 6:12. I can see that in between these two times, I've got 6 o'clock. So I need to work out how long this is and how long this is and add them together. From 5:39 to 6 o'clock is 21 minutes. And from 6 o'clock to 6:12 is 12 minutes. Adding these together gives me 33 minutes. This is how long the journey should take. Here's a question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's the next part of the question for you to try. Press pause and have a go. When you're ready for the answer, press play. For Tony to arrive in Stafford before 8 o'clock, there are 2 trains that he could catch. The one that arrives at 6:12 and the one that arrives at 7:41. We're asked for the latest train, so it's going to be this one, and the time he catches it from Stockport is 6:55. Here's the next part of the question for you. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. We're now going to look at distance tables. This table here shows the distances in miles between pairs of cities. So for example, if I wanted to find out the distance between Cardiff and Edinburgh, I would look down the Cardiff row and across the Edinburgh row and find where they cross. That's here, so the distance from Cardiff to Edinburgh is 400 miles. If I wanted to find the distance from London to Cardiff, I'd look down the London row and across the Cardiff row. Where they cross is here, that's 155 miles. So the first thing I'm asked is to write down the distance between London and Edinburgh. So I look at the London row and the Edinburgh row, and I can see where they cross, it's 413 miles. The next thing I'm asked to write down are the names of the two cities that are the least distance apart. So I'm looking for the smallest number in the table. That's 155. If I look up, I can see it's London, and if I look across, I can see it's Cardiff. So London and Cardiff are the least distance apart. For the last part, I'm told that Daniel drives to London from York. Before I read the rest of the question, I'm just going to have a look how far this actually is. So from London to York is 212 miles. I'm told he stops after 180 miles, and I want to know how many more miles he's got to drive. So I'm going to do 212 minus 180, and that's 32. So he's got 32 miles left to drive. Here's a question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. To add up these numbers, the first thing I need to do is set them out carefully. I'm going to write the 247 on the top. When I write the 76 underneath, I need to make sure that the units line up. So the 6 goes here and the 7 goes here. Now I can add these together starting at the units. So I've got 7 and 6, that's 13. So I write the 3 and carry 1. 4 and 7 is 11, plus that 1 is 12. So I write the 2, cross out the one I've used, and carry the 1 from the 12. Now I've got 2 and 1. That makes 3, and I can cross out the 1. So the answer for this question is 323. I add these up in a similar way. So I start with the 306. Now I want 47. I line the units up, then the tens. Now I want 2092. I line up the units, then the tens, then the hundreds, and then the thousands go here. And I'm adding these together. Starting with the units, 6 and 7 is 13, plus 2 is 15. So I put the 5 and carry 1. With the tens, I've got 0, 4, and 9, that's 13, plus that 1 is 14. Put the 4, cross out the one I've used, and carry the other one. 3 and 0 and 1 is 4, and cross out that 1. And 2 on its own here just gives me 2. So the answer for this one is 2,445. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now here's a wordy question for you to try. Don't worry about all the words. The maths technique that you're going to use is exactly the same. Press pause and have a go. When you're ready, press play. Here's the answer. To get it, I know that the distance is this much here, so I've got to add the 23 to the 92. Now I want to add together these two decimal numbers. To do this, I start in the same way, just by writing down the first number. So that's 14.38. Now, when I put the next number underneath, the important thing is that the decimal points have to line up. So I'm going to put that in first, and you can see I've put it under the other one. Now there's a 7 after the point, that goes here, and a 2 in front of the point, that goes here. Now I'm ready to add them. Under here there's nothing. I can put a 0 if I want to, and the same thing here. So I've got 8 add 0, that's 8. 3 add 7, that's 10. So I put a 0 and carry 1. The point goes here. 4 add 2 is 6, add that 1 is 7, and cross out the one I carried. And then I've got 1 add 0, that's 1. So the answer for this is 17.08. In a similar way for this one, I start by writing the first number down. So that's 8.29. Now this number here looks a little bit different because it doesn't have a decimal point in it. It's the number 36, and you need to remember that this is exactly the same as 36.0. So I can line this up like this, putting the point here, a 0 after it, a 6 in front of it, and then a 3 in front of that. For this one, I do have a point to line up, so that goes here. I've got 0, 3 after it, and I've got a 1 in front of it. Now I'm ready to add up. I can put a 0 in here if I want to, and here as well. 9 add 0 add 3 is 12, so put 2 and carry 1. 2 add 0 add 1 is 3, so put 3, cross out the 1. Here's the point. 8 add 6 is 14, add 1 is 15, so put the 5 and carry 1. 0 add 3 add 0 add 1 is 4, so that goes there and I can cross out the 1. So the answer for this one is 45.32. I've got one more example to show you. I start in the same way, so I write down the 4.2. Now underneath that I've got 7.8. Remember the points line up, 8 here, 7 here. Now I can add this up straight away. 2 plus 8 is 10, so I put a 0 and carry 1, and the point goes here. 4 add 7 add 1 is 12, so I put the 12 here and cross out the 1. Now the answer I've got is 12.0. Remember, in the same way as 36.0 was actually 36, 12.0 is actually 12. So this is the answer to this question. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another wordy question for you. In this one, you're not just allowed to say yes or no. You need to show full working to get all the marks for the question. Press pause and have a go. When you're ready, press play. Here's the answer. To get this, I added up the cost for 3 drinks and got this, and I added up the cost for the 2 cakes and got this. I then added up the drinks, a sandwich, and the cakes, and I got £4.75. Because Sam has got £5, she can definitely afford what she wants to buy. To subtract this number from this number, I start by writing this one down. So I've got 985. I want to put this one underneath. I need to make sure I line up the units, so that goes there, and the tens, so that goes there. Now I'm taking away, so 5 take away 3 is 2, 8 take away 4 is 4, and 9 take away nothing because there's nothing here is 9. So the answer to this question is 942. Out of interest, if you want to check your answer, if you add 942 and 43 together, you should get 985. So I've set that up here. 2 plus 3 is 5, 4 plus 4 is 8, and 9 plus nothing is 9. So you can see that this is correct. So 942 is definitely the right answer. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now subtraction is not always that easy. Let's have a look at a slightly trickier question. We start in the same way by writing the first number down, so that's 324. The second number goes underneath. Be careful to line up the units, so that's there, and the tens, that's there. Now we start with the units. 4 take away 2 is 2. But when we come to the tens, we've got 2 take away 8. Because 8 is bigger than 2, we need to do something called borrowing. What we do is we cross out the 3 and turn it into a 2, and we put the 1 that we've borrowed here. So now we've got 12 take away 8, that's 4. Then we've got 2 take away nothing, so that's just 2. So the answer for the question is 242. Let's do another tricky one. We write down the 504 with the 127 underneath. Now 4 take away 7 doesn't work because 7 is bigger than 4. When I go to borrow though, there's nothing there. So what I need to do is look at the bigger picture. I've actually got a 50, so I change that to a 49 and I put the 1 I've borrowed here. Now 14 take away 7 is 7, 9 take away 2 is 7, and 4 take away 1 is 3. So the answer to the question is 377. Now this is probably the hardest type of question you'll get. I've got 1,000 and I want to take away 236. Remember to line the units up so the 6 goes here, the 3 goes here, and the 2 goes here. Now 0 take away 6 won't work because 6 is bigger than 0. I want to borrow but there's nothing here. So look at the bigger picture. Don't just look at these 2 zeros, look at the whole thing. We've got 100. So we can borrow 1 from that to make it 99 and put the 1 we've borrowed here. Now 10 take away 6 is 4, 9 take away 3 is 6, and 9 take away 2 is 7. So the answer to this question is 764. Because this was a particularly difficult question, I'm just going to check my answer by adding this to this. And as you can see, it comes to 1,000, so I know that this must be the right answer to the question. Here are some for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's a wordy question for you now. You need to work out how much further it is to London than to Bath from the signpost. You'll need to do a takeaway to get this answer. Press pause and have a go. When you're ready, press play. Here's the answer. We're now going to look at subtracting decimal numbers. We do it in a very similar way. So we start by writing down the first number, that's 28.76. For the second number, it's important to make sure that the decimal point lines up, so put that in first. I've got 4 after it, and a 3 in front of it, and I want to take away. 6 take away 4 is 2, 7 take away 4 is 3, 8 take away 3 is 5, and 2 take away nothing is just 2. So the answer to this question is 25.32. Let's have a look at this one now. I start with this number, so that's 19.23. Line up the point, and it's got a 7 after it, and a 14 in front of it. I want to take away. Remember, if you want to, you can put a 0 here. So I've got 3 take away 0, that's 3. 2 take away 7 doesn't work because 7 is bigger than 2, so I need to borrow. The 9 becomes an 8, and I put the 1 I've borrowed here. 12 take away 7 is 5. Here's the decimal point. 8 take away 4 is 4, and then 1 take away 1 is nothing. I don't bother writing the nothing, I just leave it as it is. So the answer is 4.53. Now this question looks a bit different. This number here doesn't have a decimal point in it. You need to remember that 37 is the same as 37.0. If you can't see a point in a number, you can just put one on the end. So we've got 37.0, and we want to take away 25.56. So I put the point underneath, the 5 and the 6 afterwards, and the 25 before. Now you can see we've got a gap here. Put an extra 0 in there. So we've got 0 take away 6. That doesn't work, so I look for a borrow. There's nothing here, so I need to look at the bigger picture. I look at this 70. I change it to 6, 9, and I put the 1 in here. So 10 take away 6 is 4. 9 take away 5 is 4. There's a decimal point here. 6 take away 5 is 1, and 3 take away 2 is 1. So the answer for this question is 11.44. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's a money question for you to try now. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Before we begin this clip on multiplication, you need to make sure that you know all of your times tables up to 9 times 9. I haven't put the 0 times table on here because 0 times anything is 0. Make sure you know all of these. Press pause and review them. When you're ready to continue the clip, press play. Now we want to do this multiplication. How we set it out is really important. We start by writing the 83 on the top with the 4 underneath lining up the units, and we're multiplying these two numbers together. Now to do this multiplication, I'm going to be using the 4 times table. A reminder of the 4 times table is here. So I start with the units 4 times 3. 4 times 3 is 12. I write the 2 and carry the 1. Now I want 4 times 8. 4 times 8 is 32, and I've got to add the 1 on to get 33. I can write that in straight away because it's the last piece of the multiplication. So the answer is 332. Here are some for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now I want to multiply a 2-digit number by another 2-digit number. Again, the setting out is important. We put the bigger number on the top with the smaller number underneath. Now I'm going to need my 6 times table and my 3 times table. Those are here for me. I'm going to start by multiplying everything on the top row by 6. Once I've done this, I'm then going to multiply everything on the top row by 30, and I'm going to add the two answers together. So I start with 6 times 2. 6 times 2 is 12, so I put the 2 and carry 1. Now I've got 6 times 7. 6 times 7 is 42, and I add this 1 to get 43. So this is the top row multiplied by 6. Now I want to multiply by 30. To do this, I start by putting a 0 here. This has the effect of letting me just multiply by 3 now. So I do 3 times 2. 3 times 2 is 6, and I put this here. Then I do 3 times 7. 3 times 7 is 21, and I can write that in here. Now to get the final answer, I've got to add these two together. So I've got a 2 here, 9 here, 5 here, and just a 2 here. So the answer to this question is 2,592. When doing this type of multiplication, the big stumbling block for many people is remembering to put this 0 here. It's really important, so try to remember to do it. Now here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now I want to do this question, where I'm multiplying a 3-digit number by a 2-digit number. This number goes on the top, with the 2-digit number underneath. Make sure that you line up the units when setting up your working out. Now I want to multiply everything on the top by 4 first of all, and then everything on the top by 60, and then I add those two rows together. So I'm going to start with 4 times 7. 4 times 7 is 28, so I put the 8 and carry 2. Now I need 4 times 2. 4 times 2 is 8, plus the 2 is 10, so I put the 0 and carry 1. Now I want 4 times 3. 4 times 3 is 12, plus the 1 is 13, and I can write that in. Now, because I'm now multiplying by 60, I've got to put a 0, and then I can just multiply by 6. So 6 times 7 is 42, so I put the 2 and carry 4. 6 times 2 is 12, plus the 4 is 16, so I put the 6 and carry 1. 6 times 3 is 18, plus the 1 is 19, and I can just write that in. Now I can add these two rows together. I've got 8 here, 2 here, 3 and 6 makes 9 here, 1 and 9 makes 10, so put a 0 and carry 1, and then 1 and 1 is 2. So the answer is 20,928. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now here's an exam-style question for you. You need to do a multiplication to get the answer to this question. Press pause and have a go. When you're ready, press play. Here's the answer. You needed to multiply 907 by 8, which gives you this. Now this is the amount of pennies, and we change that to pounds by dividing by 100. So your answer is £72.56. Here's another question for you. Press pause and have a go. When you're ready, press play. Here's the answer. In this clip, we're going to be looking at dividing integers. That just means dividing whole numbers. Now, all your life, you've probably been told how difficult this is, and you've also probably been shown lots of different methods that don't really help. What I'm going to do in this clip is show you how straightforward it really can be if you use the right method. I want to divide 994 by 7. Before I do this, the first thing I actually need is the 7 times table. Here's my 7 times table. I set the question out by writing down the 994, drawing a bus shelter over it, and then putting the number I'm dividing by, in this case 7, on the outside. Now I say, does 7 go into 9? Yes, it does. It goes in once, with a remainder of 2. Does 7 go into 29? Looking here, I can see that 4 7s are 28. So it goes in 4 times with a remainder of 1. Does 7 go into 14? Yes, it does. It goes exactly twice. So the answer to this question is 142. Let's look at another example. For this one, because I'm dividing by 8, I'm going to need the 8 times table. Now, obviously, this doesn't magically appear when you're doing an exam, so you might need to write it out yourself. So it starts with 8, then 16, 24, 72, and the next one would be 80. I'm not going to need that for a division. Now I set this out. So I write 4216 inside my bus shelter with the 8 on the outside. I start by saying, does 8 go into 4? No, it doesn't, because the first number is 8 and 4 is lower than that. So what I do is I bring that 4 onto the 2 to make 42. Does 8 go into 42? Yes, it does. It goes in 5 times, but there's going to be a remainder of 2. So I put my 5 with a remainder of 2. Does 8 go into 21? Yes, it does. Twice will make 16. And then from 16 to 21, it's 5, so I've got a remainder of 5. Now, does 8 go into 56? Yes, it does. It goes in exactly 7 times. So the answer for this question is 527. Just out of interest, when I started this question and said, does 8 go into 4, and found that it didn't, You can put a 0 up here before you move the 4 along. This will help you remember that 8 doesn't go into 4. However, when you write your final answer, don't put the 0. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now I'm going to look at dividing something by a 2-digit number. So for this one, I want the 17 times table. Once I've got that, I set my question out. So I've got 272 in the bus shelter, and I'm dividing that by 17. I start by saying, does 17 go into 2? It definitely doesn't because 2 is far too small, so I put the 2 here. Does 17 go into 27? Yes, it does, but only once. That makes 17, so there's a remainder of 10 to get up to the 27. Now, does 17 go into 102? Yes, it does. You can see that it goes in exactly 6 times. So the answer for this question is 16. So for this example, I'm going to need the 32 times table. Remember, it's not going to magically appear on the exam, so you need to be able to write it out yourself. So it starts with 32. We double this to get the next number, that's 64. To get the next number, I add these two together. So 2 and 4 is 6, 3 and 6 is 9. Now to get the next one, I can double this one, and that gives me 128. To get the next one, I add 32 onto this one. So 2 and 8 is 10, 3 and 2 and the 1 from the 10 is 6, and 1 on its own is 1. Now I can just keep adding 32. So this is my 32 times table. I set the question out in my usual way. And I say, does 32 go into 1? Obviously not, because 1 is far too small, so I put the 1 here. Does 32 go into 17? No, because 17 is far too small, so I put the 17 here. Does 32 go into 179? Yes, it does. It goes in 5 times. That makes 160, so there's a remainder of 19. Does 32 go into 192? Yes, it does. It goes in exactly 6 times. So the answer is 56. So, as you can see, when we're dividing by a 2-digit number, the method is actually the same, and it doesn't make it any more difficult, really. The hard bit and the absolute key to it is being able to generate the times table for the number that you're dividing by. Here are some questions for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Let's have a look at this question now. It looks more straightforward than the ones we've just been doing, but there's a complication with it which you'll see as I do it. I need the 8 times table for it. Now I set my question up with my 28 inside my bus shelter and the 8 on the outside. And I say, does 8 go into 2? It doesn't because 2 is far too small, so I put the 2 here. Now, does 8 go into 28? Yes, it does. It goes in 3 times, so I put that 3 here. Now, I made 24, but I wanted 28, so I've got a remainder of 4. When you were younger, you might have written this with a little r and just put R4 to finish off the question. But what we can do now is take it one stage further. So I'm going to extend my division, and on the end of this number, I'm going to write 0.0. I haven't changed the number at all because 28.0 is the same as 28. Now remember, we had a remainder of 4. I can put that here. I put the point on the top as well, and then carry on. Does 8 go into 40? Yes, it does. It goes exactly 5 times. So I can put my 5 here, and you can see that we've got the answer 3.5. So we've done a really difficult division with a remainder, but we've made it look the same as the ones we've been doing so that we can get a decimal answer. Let's have a look at another example. I want the 15 times table this time. Then I set it out with the 108 inside the bus shelter and the 15 on the outside. Now, does 15 go into 1? No, because 1's too small. Does 15 go into 10? No, because 10's too small. Does 15 go into 108? Well, it goes into 105 and it goes in 7 times. So I put the 7 up here. Now I've got a remainder of 3 to get from 105 to 108. Remember, we extend the division, put 0.0 and put our remainder here. Put the point up here and carry on. Does 15 go into 30? Yes, it does, exactly twice. So the answer to this one is 7.2. Here are some for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Here's another slightly more difficult question. To do it, I'm going to need the 8 times table. We set it out as normal, 74, divided by 8. And we say, does 8 go into 7? No, it doesn't. So we put the 7 here. Does 8 go into 74? Well, it goes into 72 9 times, and there's a remainder of 2. Remember, we extend this, put a point, put a 0, put our remainder here. Put the point up here too. Now, does 8 go into 20? Yes, it does. It goes twice. That makes 16, so there's a remainder of 4. Now we can put another 0. Put the 4 on it, and then say, does 8 go into 40? Yes, it does. It goes in exactly 5 times. So the answer to this is 9.25. It's important to realise that once you've got to the decimal point, every time you get a remainder, you can put a 0 and put the remainder on, and this can go on for as long as you need it to. Here are some questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Inverse means the reverse effect. In maths, we often talk about inverse operations. Let's look at what this means. Plus and minus are inverse operations of each other because they have the reverse effect. So, for example, if we know that 4 plus 10 is equal to 14, then we can use this to write that 14 minus 4 will give us 10, and 14 minus 10 will give us 4. In a similar way, if we have that 25 minus 7 is 18, then we know that 18 plus 7 will make 25, and 7 plus 18 will make 25. It's important to notice that these two are really just the same as each other. But here we have 2 completely different number sentences with different outcomes. Times and divide are also inverse operations of each other because they reverse each other's effects. So, for example, if I know that 4 times 10 equals 40, I can write 40 divided by 4 equals 10, and 40 divided by 10 equals 4. In a similar way, if I know that 24 divided by 8 equals 3, then I know that 3 times 8 is 24, and 8 times 3 is 24. Again, it's important to notice that here we basically get the same number sentence with the same outcome, but here we have 2 completely different ones. Now, using my examples to help you, write 2 new number sentences using the inverse operation for each of these. Press pause and have a go. When you're ready, press play. Here are the answers. In these questions, I'm given one number sentence, and I'm given another number sentence here, but some of the numbers are missing. I need to fill them in using this. So I want to make 6, that tells me I've got to use the 15 and the 21. It must be 21 minus 15 to give me 6. Here, I want to make a 12, so I'm going to be using the 36 and the 3. It's going to have to be 36 divided by 3 to make 12. On this one, I want to make 30, so I've got to use the 12 and the 18. I could write 12 plus 18 or 18 plus 12. These are both correct. For this one, I want to make 24, and I've got to use the 6 and the 4. So I could have 4 times 6 or 6 times 4. These are both correct. These are slightly different. I've got to put a number in the square and an operation in the circle. I'm using inverse operations, so if this one here is a plus, this one must be the inverse, which is minus. I've got to make 17, so I can ignore the 17 and just use the 9 and the 26. So it must be 26 minus 9 to make 17. The operation here is times, so I need to put the inverse here, and that's divide. I want to make 8, so that tells me I've got to use the 4 and the 32. So it must be 32 divided by 4 to make 8. Here are some of those for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Notice that on questions C, D and F, there are 2 possibilities for your answer. You only have to write down one of them in each case. In this clip, we're going to be looking at questions involving money. We're going to focus on non-calculator questions, and we're going to look at 3 typical questions that might appear on an exam paper. In this first type of question, I'm told that James has got £1.37. I'm also told that each of the coins he has got a different value, and I've got to work out what actual coins he's got. Now, to do this, I need to know what coins we have in the UK. So if I start at the bottom, we would have a 1p, we've got a 2p, there's also a 5p, a 10p, a 20p, a 50p, and we have a pound coin as well. I'm not going to go over £1 because the amount of money he's got is only just over £1, so I'm not going to need the £2 coin. To make up £1.37, I'm definitely going to have £1. 50p would be too big because if I added that on, that would be £1.50, which is more than this. So I'm going to have a 20p, that makes £1.20. Then a 10p, that makes £1.30. A 5p makes £1.35. And a 2p makes £1.37. So I don't need the penny. So my answer is that James has a 2p, a 5p, a 10p, a 20p, and a £1 coin. So this is my answer. Now here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. In this question, there's a special offer on DVDs. They're £6 each, but they're buy 2 get 1 free, and I want to know how many DVDs you can get for £36. So if I start off buying one, that's £6. Another one would be another £6, but then I would get a third one for free, and I would have spent £12 altogether. So I can do that again. So now I've spent £24, so I can do this one more time. And now I've spent £36 altogether. So I've spent all my money, and we can see that I've got 9 DVDs. So the answer is 9. Here's a similar question for you to try. Press pause and have a go. When you're ready, press play. So every time you buy 2 packets of crisps, you get one free, and that's £1. so that's £1 of the £2.50 spent. We can do that again. We've got 6 packets now, and we've spent exactly £2. Now we've only got 50p left, so we can actually only get one more packet of crisps. So for £2.50, we can get 7 packets altogether. Now in this question, I'm told that Joe has got 76p and Tom has got £3.54. Tom's going to give Joe some money so that they've both got the same amount, and I want to work out how much Tom has to give to Joe. The first thing I'm going to do is work out how much money they've actually got altogether between them. So I've got 76p, which I write as no pounds and 76p, and £3.54. I add these two amounts of money together. So 6 and 4 is 10, put the 0, carry 1. 7 and 5 is 12, plus the 1 is 13, put the 3 and carry 1. 3 and 1 is 4. So altogether, they've got £4.30. Now, if they're going to have the same amount of money each, they've got to share this equally, so they need to split it exactly in half. So I've got half of £4.30. Half of £4 is £2, and half of 30p is 15p. So they must be having £2.15 each. Now, poor old Joe has only got 76p, so we've got to work out how much more money she needs to get up to £2.15. To do this, I'm going to get my £2.15 and take away my 76p. Remember, we write this as no pounds and 76p. 5 take away 6 doesn't work, so we borrow. 15 take away 6 is 9. 0 take away 7 doesn't work, so we borrow. 10 take away 7 is 3. 1 take away 0 is 1. So Tom has got to give Joe £1.39. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. In this clip, we're going to be looking at questions involving money, and we're going to focus on the kind of question that would appear on a calculator exam paper. Here, I'm given a list of hotel charges, so it's £49 per night for a room, £5.95 for breakfast, and £10.50 for an evening meal. Liz stays at the hotel for 4 nights. She's going to have 3 breakfasts and 2 evening meals at the hotel. We want to work out how much she pays altogether, and we can use a calculator to do this. So the first thing I'm going to write down is her nights. She spends 4 nights at the hotel, and it's £49 per night. I'm going to add to this her breakfasts. She has 3 breakfasts, and it's £5.95 per breakfast. I'm going to add to this her evening meals. She has 2 of these, and they're £10.50 each. I can now type this exactly as it appears here into my calculator. I get the answer £234.85. Now, if when you try and type this into your calculator, you find that you're not getting this answer, it's probably because you're not using a scientific calculator. You'll have to do the question this way, by finding out the answer for this part first, then this part, then this part, and adding your 3 answers together. If you add these up, you should then definitely get this total. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. In this second type of question, I'm told that Roy's pay is £299.30 per week. I'm also told that he works for 36.5 hours per week, and I want to work out his hourly rate of pay. This means how much money he gets paid per hour. To do this, I've got to get the weekly pay and divide it by the number of hours. So into my calculator, I'm going to type 299.30 for the £299.30, and I want to divide that by 36.5. Now that's going to be 36.5 because a half is the same as 0.5. I can now press the equals button and the calculator gives me the answer 8.2, but I need to translate this into a rate of pay. Well, it's in pounds and it's 8.2, but this still doesn't look right. £8.2 is actually £8.20. If you've only got one number after the point, you need to put a 0 on the end. This is Roy's hourly rate of pay. Here's one of those for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer for that one. In this question, I'm told that Sam pays the same amount for each song that she downloads. I'm told that in May, she pays £31.60 for 40 songs. In June, she pays £48.98, but I don't know how many songs she downloaded. That's what I'm being asked. How many songs did she download in June? The first thing I need to do is work out how much each song is, and I can do that using the May data. So it's £31.60 for 40 songs. So I'm going to get £31.60 and divide it by 40 to work out how much it costs per song. I get this answer on my calculator. This is telling me that it's 79 pence per song. In June, she pays £48.98, so I get that amount of money. And this time, I divide it by the cost per song to work out how many she downloaded. I get the answer 62. So in June, she must have downloaded 62 songs. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's a more difficult question for you now. You need to make sure you read it through carefully. Press pause and have a go at it. When you're ready, press play. Here's the answer. To get this, I needed to work out how much it was to go by train first of all. Anne and her 3 friends are going, so the first thing is that there's 4 people. If they go by train, it's £4.70 each, so 4 times £4.70 gives me £18.80. Then I needed to work out how much it costs to go by taxi. If they go by taxi, it doesn't matter how many people there are, but it does matter how far they go. It's 7 miles from Croydon to Bromley. The cost is £2.40 straight away, plus £2.30 per mile. So I've got 7 times £2.30 as well. Working this out gives me £18.50. Comparing the two, you can see that it's slightly cheaper to go by taxi, so they should travel by taxi. In this clip, we're going to be looking at negatives in real life. Now, one of the most common uses of negatives is in temperatures. So here we have a thermometer. 0 degrees C is freezing point. Anything above this is a positive temperature. Anything below it is a negative temperature. Notice that we show the negative temperatures with these little minuses here, but we don't put little pluses in front of the positive temperatures. So if a temperature doesn't have a sign in front of it, you can assume that it's positive. Interestingly, 0 is neither negative nor positive. So if we're asked to read the temperature on a thermometer, we simply look at how far up the line goes. On this one, we can see that it goes up to 4 degrees. So the answer for this question would be 4 degrees C. In the same way here, the answer for this one would be -1 degrees C. Now this time we're asked what the difference there is between the temperatures on the two thermometers. So here I can see the thermometer showing 4, and here it's showing -1. If I count down from 4 to -1, that's 1, 2, 3, 4, 5. So there's a difference of 5 degrees C between the temperatures on the two thermometers. I can check this by counting up on this one. 1, 2, 3, 4, 5. I do get to 4 degrees C. Notice that when we write a difference, we don't put a minus or a plus. The difference is simply the gap between the two temperatures. Here's a question for you to try. Press pause and have a go. When you're ready, press play. So the difference would be 1, 2, 3, 4, 5, 6, 7, 8. I can check this. 1, 2, 3, 4, 5, 6, 7, 8. Here's another one for you to try. Press pause and have a go. When you're ready, press play. This looks more difficult, but we do it in the same way. The temperature is here. If I go up 1, I get to here. 2 gets me here, and 3 gets me to the same level as this. So the difference is 3 degrees C. I can check it on this one. My temperature is at this level, going down 1, 2, 3 gets me to the same level as this one here. Now here we have a typical exam question. I'm given a table with the average temperature in degrees C in January in some cities around the world. I'm asked a series of questions about the table. First of all, I'm asked which city has the lowest temperature. Now I've got two negative temperatures here, -11 and -13. The lower one is -13 because it's more negative than this. So the answer is that Moscow has the lowest temperature. I want to know the difference in temperature between Toronto and Cairo. The temperature in Toronto is -11, and the temperature in Cairo is 9. So I need to know how far it is from -11 to 9. Now I know that freezing point is going to be somewhere in the middle. From -11 to freezing point of 0 is 11, and then from 0 to 9 is 9. So the total difference is 11 plus 9, which is 20 degrees C. For part C, I'm told that in July, the average temperature in Moscow is 35 degrees C higher than it is in January. And I want to work out the average temperature in Moscow in July. So, the average temperature in Moscow in January is -13. I need to go up 35 degrees from this. So, because this number here is bigger than this one, I know I'm going to go past 0. It will take me 13 degrees to get to 0. I've now got to work out how much is left. So if I take 13 off 35, I get 22. So there must be another 22 degrees to rise, and that gets me to 22 degrees C. So the average temperature in Moscow in July is 22 degrees. Here's a question for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another question for you. This one's in the context of money. You can think of profit as being positive and loss as being negative. Press pause and have a go. When you're ready, press play. In the table, you can see the answers for Part A. Here is some of the working for Part B. Now, to work out the total profit or loss, I'm going to add up the profits. So that's £2.20 plus £4.40. So that's £6.60 profit. I'm then going to add up the losses. So that's 50p, £1.50, so that's £2 so far, and another £2. So that's £4 loss. Now remember, we can think of a loss as being negative. So to work out the total profit or loss, we can do this sum and we get £2.60. Because the profit was bigger than the loss, it must be £2.60 profit. In this clip, we're going to be looking at fractions. A fraction is part of a whole. You come across fractions in everyday life. You might say to someone, "I'll meet you in half an hour." There's a fraction here, half. You might go into a fast food restaurant and order a quarter pounder and fries, please. There's a fraction here too, quarter. As a fraction, we can write half like this, and quarter like this. We know that an hour is a measurement of time that's equal to 60 minutes. So half an hour means 30 minutes. This is actually telling us to get our 1 hour and divide it by 2, and that gives us 30 minutes. Now you might order a quarter pounder without even realising what it means. A pound is a measurement of weight, and 1 pound is actually equal to 16 ounces. When you order a quarter pounder, you get a quarter of this weight of meat, and that would be 4 ounces. The fraction is telling you to get your 1 pound, which is 16 ounces, and divide it by 4, which gives you 4 ounces. It's important for you to know that in a fraction, we call the top number the numerator, and the bottom number is called the denominator. And we've already seen that this line here means that we get the numerator and divide it by the denominator. Another everyday situation where you may come across fractions is when you're cutting up a pizza. If we cut our pizza into 2 equal pieces, then this is a half of the pizza because it's 1 out of the 2 equal pieces. If we cut our pizza into 4 equal slices, then 1 piece is a quarter because it's 1 of the 4 slices. If we cut our pizza into 8 equal pieces, then we say that this is 1/8 because it's 1 of the 8 pieces. This would be 2/8 because it's 2 of the 8 equal pieces. And this would be 3/8 because it's 3 of the 8 equal pieces. Now here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In this question, I'm being asked to shade the given fraction of each of these shapes. For this one, the given fraction is 7/20. I start by looking at the denominator, and that's 20, and I can see that this grid is split into 20 equal pieces. I need to shade in 7 of them. I can choose any 7 I want. So this is one possible answer. Remember, you can shade any 7. In this one, the given fraction is 2/5. The denominator is a 5, so I need to split this into 5 equal pieces. I can do that by drawing lines down like this. You can now see that I've got 5 equal segments. The numerator is 2, so I want to shade in any 2 of them. So this is one possible answer for this question. Here are some of those for you to try. You'll need to draw the grid onto squared paper 4 times before you begin. Press pause and have a go. When you're ready for the answers, press play. Here are my answers. In each one, as long as you've got the same number of squares shaded, it doesn't matter where they are. Here, I've got 3 identical rectangles. I'm going to split the first one into 2 equal pieces, the second one into 4 equal pieces, and the last one into 8 equal pieces. If I shade in this part of the first one, then that is half of the rectangle. If I shade in the same amount here, I can see that it's still a half, but it's also 2 out of my 4 equal pieces. If I shade in the same amount here, again I can see it's still a half, but it's also 4 out of my 8 equal pieces. These are called equivalent fractions, and that means that they're all actually the same value. If you typed 1 divided by 2 into a calculator, you would get 0.5. If you did the same thing for 2 divided by 4, you would also get 0.5. And 4 divided by 8 will also give you 0.5. So all of these fractions are equivalent to a half. Now try to write down one more fraction that is also equivalent to a half. Press pause and have a go. When you're ready, press play. Now, giving you an answer for this is a bit tricky, because I don't know what you've written. There's an infinite number of different answers. The way to check that your answer is correct is to divide it on a calculator. If you get 0.5, then it's definitely equivalent to a half. I now want to write down 3 fractions that are equivalent to 2/3. I'm going to show you a few ways of quickly getting some fractions that are equivalent. The first thing I could do is start with my 2/3 and double the top and the bottom each time. So I would get 4/6, then I could double this to get 8/12, and then I could double this to get 16/24. These 3 fractions are all equivalent to 2/3. Another way is to again start with the 2/3. I'm going to multiply the top and the bottom both by 2. That gives me 4/6. To get the next one, I'm going back to the original and I'm going to multiply the top and the bottom both by 3. That gives me 6/9. Again, go back to the original and multiply the top and the bottom both by 4. That gives me 8/12. These 3 fractions are all also equivalent to 2/3. The last way I'm going to show you again starts with the original fraction of 2/3. But this time I'm going to multiply the top and the bottom both by 10. That gives me 20/30. For the next one, I'm going to multiply the top and the bottom both by 100. That gives me 200/300. And for my third fraction, I'm going to multiply the top and the bottom both by 1000. That gives me 2000/3000. Again, all of these fractions are equivalent to 2/3. Here's a question for you to try now. Write down any 3 fractions that are equivalent to 4/5. Press pause and have a go. When you're ready for the answers, press play. Here are just some of the answers that you could have put. If you've got anything different and you want to check that it's correct, then divide the top by the bottom on a calculator. For any fraction that's equivalent to 4/5, you should always get the answer 0.8. Here's a non-calculator exam-style question for you now. Press pause and have a go. When you're ready, press play. So the first fraction is 4/10. To get from 2 to 4, I multiply by 2. If I multiply 5 by 2, I do get 10, so this one is equivalent to 2/5. For this one, to get from 2 to 8, I multiply by 4. If I multiply 5 by 4, I do get 20, so this is equivalent. For this one, to get from 2 to 10, I multiply by 5. If I multiply 5 by 5, I don't get 40, I get 25, so this one is not equivalent. For this one, to get from 2 to 20, I multiply by 10. If I multiply 5 by 10, I do get 50, so this one is equivalent. To get from 2 to 6, I multiply by 3. If I multiply 5 by 3, I get 15, not 20, so this one is not equivalent. So these are the two fractions which are not equivalent to 2/5. Here I have 3 identical rectangles. I've split this one into 8 equal pieces, this one into 4 equal pieces, and this one into 2 equal pieces. You can see that I've shaded the same amount of each one green. Here I've shaded in 4/8. Here I've shaded 2/4, and here I've shaded a half. These are all equivalent fractions. This one, a half, is the simplest form of these two fractions, because it uses the smallest possible numbers to express this amount. Let's say I wanted to write the fraction 12 over 20 in its simplest form. I would start with my fraction, and what I'm doing now is looking for a common factor, a number that goes into 12 and also goes into 20. I can see that 2 goes into both of them, so I'm going to divide by 2. Dividing 12 by 2 gives me 6, and dividing 20 by 2 gives me 10. Now I look at this fraction. Again, there's a common factor here of 2, so I'm going to divide the 6 by 2, that gives me 3, and I'm going to divide the 10 by 2, that gives me 5. If I look at these numbers now, I can see that there's no common factor of 3 and 5 other than the number 1. So I can't divide this anymore, and this is the simplest form of 12 over 20. Now, if you're pretty good with numbers, you can actually see a faster way of doing this. Instead of dividing by 2 and then dividing by 2 again, when you look for a common factor, you might notice that 4 goes into 12 and 4 goes into 20. So if I divide 12 by 4, I get 3, and if I divide 20 by 4, I get 5. This time, I've got the simplest form much more quickly than I did here. Here's one for you to try. Press pause and have a go. When you're ready for the answer, press play. So for this one, we have the fraction 15 over 35. We're looking for a common factor. 5 goes into 15 and it also goes into 35, so I'm going to divide by 5. 15 divided by 5 is 3 and 35 divided by 5 is 7. If I check this for common factors now, I can see that only 1 goes into 3 and 7, so I can't divide this by anything to make it smaller, so this is the simplest form. Finally, here are some more questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I'm being asked to find the number that's in the middle of 2 and 8. To do this, I could write all of the numbers out like this: 2, 3, 4, 5, 6, 7, 8. Now I can easily see that the middle number is 5. There is a slightly faster way. That's to add the 2 and the 8 together, so 2 plus 8 gives me 10, and then divide this by 2. 10 divided by 2 gives me the middle number, which is 5. This method will always work. Add the two numbers together and then divide by 2. So to find the middle of 13 and 24, I can add them together. 13 plus 24 gives me 37, and then I can divide this by 2. 37 divided by 2 is 18.5, so 18.5 is the middle of these two numbers. Here are some questions for you to try. When you get to the last one, don't worry about the negative number, just do it in the same way as the others. You can use a calculator for these if you like. Press pause and have a go. When you're ready, press play. Here are the answers. A factor of a number is a number which divides into it without leaving a remainder. To explain what I mean, I'm going to write down all the factors of 10. 1 definitely goes into 10, and it goes in 10 times, so 1 and 10 are both factors of 10. 2 goes into 10 5 times, so we have another pair here. Now there aren't any numbers in between 2 and 5 that go into 10 without leaving a remainder. 3 doesn't go in and 4 doesn't go in, so I know now that I've got all of the factors of 10. In the same way, I'm going to quickly write down the factors of 12. So 1 goes into 12 12 times, 2 goes into 12 6 times, and 3 goes into 12 4 times. There aren't any numbers in between 3 and 4 that go into 12 without leaving a remainder, so this is the final answer. Here are 2 for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. It's a good idea to separate the numbers with commas to make it easier to read. A multiple of a number is any number which appears in its multiplication table. To show you what I mean, I'm going to write down the first 5 multiples of 6. So I want the first 5 numbers in the 6 times table. So I start with 1 times 6, which is 6. 2 times 6 is 12. 3 times 6, 18. 4 times 6, 24. And 5 times 6, 30. These are the first 5 multiples of 6. Here are 2 for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Prime numbers are very special numbers. A prime number is a number which has exactly 2 factors. Let's look at the numbers 1 to 10 and decide which of them are prime numbers. If we think about the factors of 1, there's only one number that goes into 1, and that's 1. This isn't 2 factors, so that's not a prime number. The numbers that go into 2 are 1 and 2. This is exactly 2 factors, so this is prime. The numbers that go into 3 are 1 and 3. Again, that's 2 factors, so that's a prime number. The numbers that go into 4 are 1, 2, and 4. That's 3 factors, so that's not prime. 5 has 2 factors, 1 and 5, so that's prime. 6 has the factors 1, 2, 3, and 6, so that's not prime. 7 has the factors 1 and 7, so that is prime. 8 has the factors 1, 2, 4, and 8, so that's not prime. 9 has factors 1, 3, and 9, so that's not prime. And 10 has factors 1, 2, 5, and 10, so that's not prime. So I can now see the first 4 prime numbers are 2, 3, 5, and 7. Now try and find the 5th and 6th prime numbers for yourself. Press pause and have a go. When you're ready, press play. The next number in our list would be 11, so let's try and see if that one's a prime number. The factors of 11 are 1 and 11, so yes, it is prime. The next number would be 12. The factors of 12 are 1, 2, 3, 4, 6, and 12. That's way too many factors, so that's definitely not prime. Now let's try 13. The factors of 13 are 1 and 13, so that is prime. So the fifth prime number is 11, and the sixth prime number is 13. We now know how to work out whether any number is a prime number or not, but it's often helpful to know the first 5 prime numbers off by heart. They're 2, 3, 5, 7 and 11. Make sure that you memorise these. Here's a question for you to try now. Press pause and have a go. When you're ready for the answer, press play. Here's my answer. When you're explaining why Emily is wrong, you need to give a clear justification of why 15 is not a prime number. Mention that prime numbers have 2 factors, but 15 has got 4 factors. Here's another one for you to try. Press pause and have a go. When you're ready, press play. Here's my answer. You need to explain that every even number greater than 2 will have more than 2 factors. I've done it by saying that 1 will go into the number itself will go into the number, and 2 will go into the number. Here's another question for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's your final question to try. Press pause and have a go at it. When you're ready for the answers, press play. Here are the answers. In this clip, we're going to be looking at this kind of question. In maths, we always like to write things as simply as possible. So instead of writing out all of these like this, we can actually write them in a faster way, which looks like this. Here you can see I've got 2 2's multiplied together, so I write it as 2 with a little 2, and we say 2 to the power of 2. There's actually another way of saying this though, which you might have heard, and that's 2 squared. Here I've got 3 2's multiplied together, so it's 2 with a little 3, and we say 2 to the power of 3. Again, you might have heard 2 cubed. On this one, you can see we've got 4 of them, so we write 2 with a little 4. Now, there isn't a nice way of saying this one, we just have to say 2 to the power of 4, and that goes for anything 4 or more. We call this little number the power or the index. The big number, which is the number we're actually multiplying together, is the base. When things are written like this, we say that they're written in index notation. Just out of interest, although this number here is an index and this number here is an index, if we talk about them together, we don't say indexes, we say indices. Now, if I wanted to just write the number 2, but I wanted to write it using index notation like these, what index do you think it would have? Well, there's only 1 2, so it's going to be 2 to the power of 1. This is really important to remember, that 2 means 2 to the power of 1, and vice versa, that 2 to the power of 1 just means 2. Here are some questions for you now. You don't need to work out the answers to these, you've just got to write them using index notation. Press pause and have a go. When you're ready, press play. Here are the answers. Now we're going to look at multiplying 2 numbers with indices. We can do this as long as the base, remember that's the big number, is the same. To do this, you need to remember that 2 to the power of 3, or 2 cubed, is 2 times 2 times 2. 2 to the power of 4 is 2 times 2 times 2 times 2. And we're multiplying these together. Now count how many 2's you've got. There's 1, 2, 3, 4, 5, 6, 7. So this is 2 to the power of 7. Now you don't always have to write all of these out to get the answer. If you look carefully, you'll notice that 3 and 4 add up to make 7. This isn't a coincidence, this will always work. So to look at another example, if we had 3 to the power of 5 times 3 to the power of 4, instead of writing out all the 3's, I could just say 5 add 4 is 9, so that's 3 to the power of 9. Here are some of those for you to try now. Press pause and have a go. When you're ready, press play. Here are the answers. I hope that question C didn't catch you out. You need to remember that 4 is 4 to the power of 1. You can then add the powers to get 7. Now let's look at division. Division is the opposite of multiplication. So instead of adding the powers, this time I can do the opposite, which would be to subtract them. So 6 take away 4 is 2, so the answer to this would be 5 to the power of 2. If you want to see why this works, then we can write it out. 5 to the power of 6 is 6 5's all multiplied together. Like this. And this is divided by, which I can write as a line, 5 to the power of 4. So that's 4 5's all multiplied together. Now when I have something like this, I'm allowed to cancel out 5's on the top with 5's on the bottom. So I can cancel this one and this one, this one and this one, this one and this one, and this one and this one. This just leaves me with 2 5's multiplied together, which is 5 to the power of 2. Here are some for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In this clip, we're going to be looking at multiplying and dividing by powers of 10. To multiply a number by 10, we move the digits one place to the left whilst keeping the decimal point where it is. Now that sounds really complicated. But there's actually a nicer way of thinking about it. As Einstein once said, everything is relative. So instead of moving the numbers around the decimal point, what we can do is move the decimal point one place to the right. So to multiply this number by 10, my first problem is that I need to find the decimal point. If it doesn't have one, it must be at the end. So this number is really 7.0. To multiply it by 10, I move the decimal point one place to the right, and it falls off the end of the number. So the answer is 70. In the same way here, we can't see the decimal point, so it must be at the end. So this is really 32.0. To multiply it by 10, we move the point one place to the right, and it falls off the end, leaving us with 320. Now this time we can see the decimal point, it's here. So we just move it one place to the right. Again, it's fallen off the end and it's left us with 0,4. But we would never say 0,4, we just say 4. And for this one, here's the point. Move it one place to the right and it lands here in between the 5 and the 6. So we've got 25.6 when we multiply this number by 10. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Now if I want to multiply a number by a higher power of 10, I just have to move the decimal point the right number of places. So if I want to multiply by 100, because it's got 2 zeros, I want to move the decimal point 2 places to the right. So for example, let's say I've got the number 3 and I want to multiply this by 100. First of all, the decimal point is here on the end, so it's really 3.0. So I'm going to move the decimal point 2 places to the right, and it drops off the end. But we've got this space here where we can put another 0. So the answer is 300. Let's do another one. Let's say 7.4. I want to multiply this by 100, so I move the point 2 places to the right. Again, I've got this space here, and I can put a 0 in it, so the answer is 740. In the same way, if we want to multiply by 1,000, because there's 3 zeros here, we move the decimal point 3 places to the right. So let's say I wanted to multiply 4 by 1,000. I put on my point, and it's 0.0, then I go 1, 2, 3, and I've got space here for a 0 and space here for a 0, so the answer's 4,000. If I want to multiply 0.23 by 1,000, here's the point, and I move it 1, 2, 3. There's a space here for a 0, so my answer is 0230, but we don't write this here, so it's just 230. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here are some more for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Now, if we want to divide a number by 10, we move the decimal point 1 place to the left instead of to the right. So the number 7 doesn't have a point, that means it must be at the end. We move it 1 place to the left, which puts it here. Whenever we've got nothing in front of a point, we can put a 0. So 7 divided by 10 is actually 0.7. Here, decimal point's at the end. Move it 1 place to the left, and it goes in between the 3 and the 2. So we get 3.2. Move the decimal point 1 place left, and it lands here. Remember, when there's nothing in front of it, you can put a 0. So we've got 0.04. And again here, move it 1 place left, put it there, put a 0 in front of it, and we've got 0.256. In a similar way, if you want to divide by 100, move the point 2 places left, and if you want to divide by 1,000, move the point 3 places left. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here are some more for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. And here are some more for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. To finish, here's a mixture of questions for you. Press pause and have a go. When you're ready, press play. Here are the answers. In this clip, we're going to be looking at rounding numbers. I'm being asked to round the number 63 to the nearest 10. Now, 63 is in between the numbers 60 and 70. I need to decide which of these it's closer to. Well, it's only 3 away from 60, but it's 7 away from 70. So, 63 rounded to the nearest 10 is 60. If we look at this in more detail on our number line, we can see that 63 is here. Another way to decide which one it's closer to is to say, where is it in relation to the 65? If it's below 65, then we go to 60, and if it's above 65, then we go to 70. This one's definitely below 65, so 63 to the nearest 10 is definitely 60. Now, this system of saying, is it less than or more than 65 works beautifully until we get to the number 65. If I want to round this to the nearest 10, what do? Well, 65 is exactly in the middle of 60 and 70. So we have a convention. If we're exactly in the middle, then we always round up. So 65 rounded to the nearest 10 is actually 70. So if I want to round 546 to the nearest 10, I know it's going to be between 540 and 550. The middle number is 545. 546 is above this, so it's going to round to 550. Again, we can see this on the number line. Here's 545, 546 is here, and you can see it's closer to 550. Now for this one, I can see that 296 is in between 290 and 300. The middle of these two is 295, and 296 is this side, so it's closer to 300 than it is to 290. So rounding this to the nearest 10 gives me 300. Here are some for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Now this is a similar question, but this time I'm being asked to round to the nearest 100. 873 is in between 800 and 900, and the midway point of these would be 850. 873 is in this side, so it's closer to the 900. So 873 rounded to the nearest 100 is 900. Here are some of those for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. On this question, I'm being asked to round to the nearest 1,000. So 9,427 is in between 9,000 and 10,000. Now the middle point of these two is 9,500. 9,427 is this side of the 9,500, so it's closer to 9,000 than it is to 10,000. So the answer to this is 9,000. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Here's a mixture of questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. If someone asks you how much you weigh, you wouldn't reply like this, because it's far too precise. Instead, you're more likely to say something like this. This number has been rounded to 1 decimal place, and in this clip we're going to be looking at how we actually do this. So let's say I want to round this number to 1 decimal place. First of all, that means I'm allowed 1 digit after the decimal point. So my cut-off line is here, and I draw that on. Now I know that my answer is either going to be 17.8 or it might be 17.9. To work out which one it is, I need to look at this digit here. If this particular digit here is a number less than 5, so that's 0, 1, 2, 3 or 4, which as you can see this is, then this number, the 17.8, stays as it is at 17.8. So this number, rounded to 1 decimal place, is 17.8. Let's look what happens if we change the question slightly. You'll notice now that the digit that I'm concerned with immediately after my cut-off line is a 7. If the digit is 5 or more, so that's 5, 6, 7, 8 or 9, then this actually goes up. So it doesn't stay at 17.8, it goes up to 17.9. So this number, rounded to 1 decimal place, is 17.9. So to summarise, when rounding to one decimal place, we want one digit after the point, and we draw a cut-off line straight after that. We then look at the number the other side of the cut-off line. If it's 5 or more, then we go up, so this would go to 17.9. If it's less than 5, then this stays as it is at 17.8. So if I want to round this to one decimal place, I count one number after the point and draw my cut-off line. Then I look at this number here. I can see it's a 5, which tells me that this is going to go up to 7.7. For this one, draw my cut-off line and look at this number. This time it's less than 5, so this stays the same at 26.7. For this one, here's my cut-off line. Look at this number. It's more than 5, so this is going to go up to 592.9. And finally for this one, here's my cut-off line. The number here is an 8, which is more than 5, so this is going to go up, and it's going to go up from 2.9 to 3.0. When you do a question like this last one, it's really important to put the 0 on the end. That tells whoever is reading your work that the number has been rounded to one decimal place. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Now we're going to look at rounding a number to two decimal places. The technique is basically the same. We're allowed 2 digits after the decimal point, so this is our cutoff this time, and we're going to look at this number. If it's more than 5, we round up. In this case it is. So we go from 17.83 to 17.84. So this is this number rounded to 2 decimal places. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Again, it's important on the last one to leave the 2 zeros here to show that you have actually rounded your number to 2 decimal places. Here's a selection of questions for you to try now. Press pause and have a go. When you're ready, press play. Here are the answers. I'm being asked to multiply 3.27 by 6.4. What I'm going to do is ignore the decimal points and multiply 327 by 64. I like to use the column method for multiplication. So I have 4 times 7, that's 28, so I put the 8 and carry 2. 4 times 2, that's 8, plus the 2 is 10, so I put the 0 and carry 1. And 4 times 3 is 12, plus the 1 is 13. Now because I'm now going to multiply by 60, I put a 0 here, then I can treat it as if it's 6. So I've got 6 times 7, that's 42, so put the 2 and carry 4. 6 times 2, that's 12, plus the 4 is 16, so put the 6 and carry 1. And 6 times 3 is 18, plus the 1 is 19. Now I can add these together. 8 add 0 is 8, 0 add 2 is 2, 3 add 6 is 9, 1 add 9 is 10, so put 0 and carry 1, and then 1 add 1 is 2. So 327 multiplied by 64 is 20,928. So I know that the answer to this question will have the same digits. All I need to do is work out where to put the decimal point. To do this, I count the number of decimal places in the question. I've got 1, 2, 3 all together. So in my answer, I need to have 3 decimal places as well. So that's 1, 2, 3. The decimal point will go here in between the 0 and the 9. I like to check my answer by saying that this number here is close to 3 and this is close to 6. 3 times 6 is 18, so my answer needs to be as close to 18 as I can get it using these digits. Putting the point here to make 20 point something is as close as I'm going to get, so this is the right answer. So to summarise, to multiply decimal numbers, I take out the decimal points, multiply the numbers together, and then put the decimal point back in by counting the number of decimal places that I need. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's an exam-style question for you now. Although this is money that you're multiplying, you're going to use the same technique. Press pause and have a go. When you're ready, press play. Here's the answer. Here's your final question. Press pause and have a go. When you're ready, press play. And here's the answer. In this clip, we're going to be looking at dividing by 2-digit decimals. But before we do that, we need to be able to understand something. We all know that the answer to 6 divided by 2 is 3. Now, if I multiply this 6 by 10 to give me 60, and multiply this 2 by 10 as well to give me 20, what do you think the answer to this question is? It's still 3. So multiplying both numbers by 10 has meant that I've still got the same answer. If I multiply both of these numbers by 100, I get 600 divided by 200. And the answer to 600 divided by 200 is still 3. So I can multiply these numbers by 10, or by 100, or even by a larger number, and still get exactly the same answer each time. We can now use what we've just noticed to answer a question like this. I don't want to divide by 0.4 because it's really difficult, but what I can do is multiply both of these numbers by 10. That will give me 80 divided by 4. Now I know that the answer to this question will be exactly the same as the answer to this question. 80 divided by 4 is 20, so I know that the answer to this is 20. Now we're going to use this technique to answer questions like these. For the first question, I want to multiply this number by 10 to make it a whole number, so I'm going to have to multiply this by 10 as well. I get 45 divided by 15. The answer to this question is 3, so the answer to this question will also be 3. One thing to notice is that when we've multiplied both of these numbers by 10, we've moved the decimal point 1 to the right each time because there's 1 0 in the number 10. For this question, I need to multiply by 100 to make this a whole number. So I've got to multiply this by 100 as well. I get 600 divided by 3. 600 divided by 3 is 200, so the answer to the original question is also 200. Again, you might like to think of moving the decimal point 2 places to the right when you multiply by 100. For this one, to make this a whole number, I need to multiply by 100. Remember, I'm moving the decimal point 2 places to the right, so I do the same in this number. Moving the decimal point 2 to the right gives me 268.2, and I'm dividing that by 18. Now I can't easily do this question in my head, but I can do a bit of side working. So I'm going to use the bus shelter method. 18 does not go into 2, so I move the 2 to here. Now 18 does go into 26 once with a remainder of 8. 18 goes into 88 4 times with a remainder of 16. My point is here, and then 18 goes into 162 exactly 9 times. So the answer to this question is 14.9, and the answer to the original question is 14.9. So to summarise, we don't like dividing by decimal numbers, so we need to multiply both numbers in the question by 10 or 100 to turn the decimal that we're dividing by into a whole number. Once we've done this, we can answer the question. Here are some questions for you to try. On some of these questions, you might need to do some side working. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I'm going to show you how to use the number line here to answer questions like these. The first one is simple, and you should have been answering questions like this all your life. We've got 4 plus 2, so we know that the answer is 6. However, if we want to use the number line, we start at 4, and because we're adding, we move in this direction by 2. We can see that we get 6. For the next question, I want to start at the -2 and add on 6. On the number line, this looks like this. Because I'm adding, I move to the right. You can see that I get 4. In this question, we know that 5 take away 2 is 3, but if we want to see it on the number line, we need to start at 5 and move 2 to the left because we're subtracting. You can see that we get 3. For this question, I want to start at the 2 and subtract 5. So I start at the 2 on the number line and move 5 to the left. I get -3 this time. Notice that 5 minus 2 gave us the answer 3, and if we turn the question around and have 2 minus 5, it gives us the answer -3. We'll be using this later on in this clip. For the last question, I need to start at the -1 and take away 4. That means I'm going to start here and move 4 to the left. I get -5. So to summarise, when I'm adding, I move to the right on my number line, and when I'm subtracting, I move to the left. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Sometimes you'll want to be able to answer questions like these without using a number line, particularly when the numbers are larger. -12 plus 20 can be rewritten as +20 minus 12. Now, if I can get the answer to this, it will be the same as the answer for this. And I know that 20 take away 12 is 8, so the answer's 8. In the same way for this one, I can rewrite it as +67 minus 34. Now 67 minus 34 is 33, so the answer here is 33. For this one, I remember that 4 minus 17 will have a similar answer to 17 minus 4, but it will be negative. 17 minus 4 is 13, so 4 minus 17 is -13. In the same way here, 100 minus 14 is 86, so 14 minus 100 is -86. Here are some of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I'm now going to show you how to deal with questions like this, where you've got signs next to each other in between the numbers. The rules to remember when you have two signs next to each other are if the two signs next to each other are different, then you replace them with a negative, like this. And if the two signs next to each other are the same, then you replace them with a positive, like this. So for this first question, the two signs that are next to each other are different, so I'm going to replace them with a minus. I've now got 5 take away 2. I could do this using the number line, but I don't really need to. 5 take away 2 is 3. For this one, the two signs that are next to each other are different, so I replace them with a minus. So I've got minus 3, minus 1. I'm going to use the number line for this one. It looks like this, and the answer is minus 4. In this one, the signs next to each other are the same, so I replace them with a plus. I've now got 3 add 2, and that's 5. And for the last one, the signs that are next to each other are both the same, so I replace them with a plus. And I have minus 4 plus 8. I can use the number line to help me with this. It looks like this, and the answer is 4. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here are some more difficult questions for you. This time the numbers are larger and you don't have a number line to help you. Press pause and have a go at these. When you're ready for the answers, press play. Here are the answers. I'm now going to show you how to deal with negative numbers when you're multiplying and dividing. The rules for multiplying and dividing are that if the signs of the two numbers are different, then the answer will be negative, like these here. And if the signs of the two numbers are the same, then the answer will be positive, like these ones here. Now the first question is just 5 times 2. This is a straightforward question, so don't overcomplicate it. We know that 5 times 2 is just 10. But here we've got 5 times negative 2. Now because the 5 doesn't have a minus in front of it, I know that it must be a positive number. So I've got a positive times a negative. The two signs are different, so the answer's going to be a negative. And I already know that 5 times 2 is 10. So the answer for this question is negative 10. So for this question, remember that this 2 is really a positive. This is a negative. So the signs are different, it's going to be a negative, and 5 times 2 is 10. So the answer is minus 10. For this one, I've got a minus here and a minus here. So the signs are the same. That tells me the answer will be positive, and again, I know that 5 times 2 is 10. So the answer for this question is 10. Dividing works in a very similar way. We know that 12 divided by 3 is 4. For this one, the answer is going to be minus 4, because this is a positive, this is a negative. The signs are different, so the answer will be negative. For this one, again the answer will be minus 4. This is negative, this one's really positive, the signs are different, so the answer will be negative. And here, I can see that I've got 2 negatives, so the signs are the same. That tells me that the answer will be 4. Please notice that when the answer is negative, I've got to include the negative sign. But if the answer is positive, I don't need to include the positive sign. Here are some questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Finally, Here's a mixture of addition, subtraction, multiplication and division questions for you. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. The product rule for counting is a simple way of working out how many combinations of things you can have. Let's see it in action. So Sally chooses a starter and a main. We want to know how many combinations she could order. There are 2 starters, and we multiply this by the number of mains, which is 3. 2 times 3 is 6, so there are 6 possible combinations she can order. Here's one for you to try now. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. We can now extend the idea for when we've got 3 things that we want to combine. Neil's buying furniture. He wants a settee, a coffee table and an armchair. There's a choice of 3 settees, 6 coffee tables and 10 armchairs. So to get the number of different combinations, we multiply these together and that gives us 180. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. In this slightly more difficult question, we're being asked to help make up a 6-character password for a website. It's got to begin with 2 letters, and then it's got to have 4 digits. But this is what makes the question more difficult. No letter or digits can be repeated. I want to know how many passwords are possible. So, first of all, it's got to begin with a letter. Obviously, we've got a choice of all 26 letters of the alphabet. We then want a second letter, but we're not allowed to repeat the first letter, so now we've only got 25 letters of the alphabet left. Now we're going to move on to the digits. For the first digit, it can be anything from 0 to 9. That's a total of 10. For the second digit, I mustn't repeat the first digit, so I've only got 9 digits left. For the third one, I'll have 8 digits left, and for the fourth one, I've got 7 digits left. To get the total number of passwords that are possible, I need to multiply this out. And the answer is 3,276,000 different passwords are possible. Here's a similar question for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. We're now going to look at actually listing all of the possible combinations for some simple situations. We're told that Dan goes to a restaurant and the menu is over here. He chooses 1 main course and 1 dessert. What we want to do is systematically list all the possible combinations that he could have. So I'm going to start by saying he has steak for his main course. Now with his steak, he could have cake for his dessert, or he could have ice cream for his dessert, or he could have trifle for his dessert. So this gives us the first 3 combinations. To find the next 3 combinations, I'm going to change his main course from steak to fish. So he could have fish followed by cake, fish followed by ice cream, or fish followed by trifle. This gives us 3 more combinations, taking us to a total of 6. To finish off, I'm going to change his main course to vegetarian and put that with each of the 3 desserts. This gives us the final 3 combinations, so we've got a total of 9 altogether. Just out of interest, notice that we had 3 different mains and 3 different desserts. If we multiply these 2 numbers together, we get 9, and this tells us how many combinations there are going to be. Again, notice when I was doing it, I worked systematically, putting each main with the 3 different desserts in turn. Here's one for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try. Remember to try to work systematically. Press pause and have a go. When you're ready, press play. Here are the answers. You'll notice that I started by starting the numbers with a 3. So I got 368 and then I changed the 6 and the 8 around to get 386. Then I started with a 6, so I got 638 and switched those around to get 683. And then I started with the 8, getting 836 and switching these around to get 863. Yours might be in a different order, but you should still have all 6 of these numbers. Here's another one for you to try. Make sure you read this question carefully before you begin. Press pause and have a go. When you're ready, press play. Here are the answers. Again, yours might be in a different order, but you need to make sure you've got all 6 seating arrangements. Here's another question for you. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another question for you. Again, make sure that you read this one carefully before you try it. Press pause and have a go. When you're ready, press play. Here are the answers. Here's a question you would never see on an exam paper. We want to put these fractions in order of size from smallest to largest. Because the denominators of these fractions are all the same, it's nice and straightforward to do. We just need to put the numerators in order. So it would be 1/7, then 2/7, then 3/7, then 4/7, and we'd finish with 6/7. Now, in a real exam situation, the question won't look like this at all. A real exam question would look like this. But what we're going to do is make the denominators all the same so that it looks like the question we've just done. What we need to do is find a number that all of these denominators will go into. We call this a common denominator. It always makes sense to look at the largest number you've got. I've got 20 here. Now 2 goes into 20, 5 goes into 20, and 10 goes into 20, but 8 doesn't, so I need to go a little bit bigger. 2 20s are 40, so let's try 40. 2 goes into 40, 8 goes into 40, 5 goes into 40, 20 goes into 40, and so does 10. So 40 is my common denominator. So I'm going to rewrite all of these fractions with a denominator of 40. 2 goes into 40 20 times, so I've multiplied this by 20. 1 times 20 is 20. 8 goes into 40 5 times, so I multiply this by 5. 3 times 5 is 15. 5 goes into 40 8 times, so I multiply this by 8. 2 times 8 is 16. 20 goes into 40 twice, so I multiply this by 2. 11 times 2 is 22. And finally, 10 goes into 40 4 times, so I multiply this one by 4 and get 32. Now I can easily compare. So I'm just going to focus on the numerators. I can see that 15 is the smallest, so this is the smallest fraction. But remember, I'm not writing these ones, I've got to write the ones I was originally given. So the smallest one is 3/8. The next one is this one, 16. So it's 2/5. Next biggest is 20, so that was a half. The next biggest numerator is 22, That was 11 over 20. And we can finish off with this one here, 8 over 10. These fractions are now in order of size from smallest to largest. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here are the fractions in order. At this stage here, you might have used a different common denominator. For example, you could have used 24. You should still get the fractions in the same order though. Here's another one for you to try. Press pause and have a go. When you're ready, press play. Here are the fractions in the right order. Again, your working out may have been a bit different. You could have used a different common denominator. For example, here, 48 would work as well, but you should get the fractions in the same order. Here's your final question. Press pause and have a go. When you're ready, press play. Here's the answer. In this clip, we're going to be looking at adding and subtracting fractions. To introduce this, let's look at something that we already know about. If I draw a box and split it into 4 quarters, we can see that one of these quarters plus another one gives us 2 quarters. And if we look at the picture carefully, we can see that we've actually coloured in a half of the box. So 1 quarter plus 1 quarter equals a half. Let's look at another one. If I draw a box and split it into 5 equal pieces, these are fifths. So 2/5 will look like this. And if I colour in another 1/5 as well, we can see that the total is 3/5. And in the same way, if I do this one without a picture now, 2/7 add 3/7 must be 5/7. So you can see we add the numerators, but the denominator stays as a 7. When we're subtracting, we do a very similar thing. So here we've got 7/10 minus 3/10. So we do 7 take away 3, that's 4, and then the denominator stays as a 10. This one can be simplified. If I divide both numbers by 2, I get 2 over 5. For this one, 5 take away 2 is 3, and the denominator stays as a 6. This one can be simplified as well. If I divide the top and the bottom both by 3, I get 1 over 2. Here are some questions for you to try. Try and give your answers in their simplest forms. Press pause and have a go. When you're ready, press play. Here are the answers. Here's a slightly harder question now. I've got 5/8 plus 7/8. So I've drawn a rectangle and I've split it into 8 equal pieces. I'm going to start by shading in 5 of them. So this is my 5/8. I've got to add 7/8. But you can see that I've only got 3/8 here. So I'm going to need another block of 8s to be able to add on 7 altogether. So here's my other block of 8s. Remember, I wanted to add 7/8 and I had 3 here, so I'm going to need another 4. Now we can see that 5/8 plus 7/8 makes 8, 9, 10, 11, 12 eighths altogether. What we've got now is called a top-heavy fraction. What I want to do is now give my answer in its simplest form. I can see that both of these numbers will divide by 4, so if I do that, I get 3 over 2. This is still top-heavy, but the numbers are as small as I can get them, so this is the simplest form. Some people don't like that it's a top-heavy fraction and prefer to say, how many 2's go into 3? 1, remainder 1, and we put this one back over the 2 again. So the answer to this question is 3 over 2 or 1.5. This is a top-heavy fraction in its simplest form, and this is a mixed number in its simplest form. Both of these answers would be accepted on the exam. So for this one, the denominators are the same, so I can simply add the 3 and the 6 to get 9 and leave the denominator as a 7. Can I simplify this at all? No, I can't, but what I can do is change it to a mixed number. 7 goes into 9 once with a remainder of 2, and this goes back over the 7. So an answer for this question would be either 9 over 7 or 1 2/7. In the same way here, 4 add 10 is 14, and that will go over 12. 2 goes into both of these numbers, so I can divide both by 2 to get 7 over 6. This is the simplest form as a top-heavy fraction. I can change it to a mixed number if I want to. 6 goes into 7 once with remainder 1, and this goes back over the 6. So accepted answers for this one are 7 over 6 or 1 1/6. Here are some questions for you to try. Remember to give your answers in their simplest forms, either as a top-heavy fraction or as a mixed number. Press pause and have a go. When you're ready, press play. Here are the answers. C is a bit special. When you add them up, you get 6 over 6. If you ever get the same numerator and denominator, you mustn't leave it like this. 6 over 6 is actually 1, and this is the answer that you need to give on the exam. If we look at this question now, we can see that the denominators are different. This prevents us just adding it up straight away. What we need to do is convert them to two fractions where the denominators are the same. The way I do this is by multiplying all of this fraction by 4 and multiplying all of this fraction by 3. So 1 times 4 is 4 and 3 times 4 is 12. 3 times 3 is 9 and 4 times 3 is 12. Now you can see my denominators are the same and I can carry on as normal. 4 add 9 is 13 and this goes over 12. This is an acceptable answer, but you might like to turn it from a top-heavy fraction into a mixed number. 12 goes into 13 once with remainder 1 and this goes back over the 12. So your answer for this question is 13 over 12 or 1 1/12. So for this one, I'm going to multiply this fraction by 3 and this fraction by 7. So 5 times 3 is 15 and 7 times 3 is 21. 2 times 7 is 14 and 3 times 7 is 21. Now I can add the numerators to get 29 and this is over 21. I can leave it like this or change it to a mixed number. 21 goes into 29 once with a remainder of 8. So this is 1 8 over 21. Either of these two are the acceptable answer. Subtraction works in a similar way. I'm going to multiply this by 6 and this by 9. So I have 8 times 6, which is 48, over 9 times 6, which is 54. Take away 5 times 9, which is 45, over 6 times 9, which is 54. Now 48 take away 45 is 3, so I've got 3 over 54. Now this isn't the simplest form. 3 goes into both of these numbers, so I'm going to divide them both by 3. 3 goes into 3 once, and it goes into 54 18 times. So the simplest form of this is 1 over 18. Just out of interest, if you're good with number, you might have spotted that there's a different way of getting a common denominator here. 9 and 6 both go into 18. 9 goes into 18 twice, and 6 goes into 18 3 times. If I do this now, I've got 8 times 2, which is 16, over 9 times 2, which is 18, take away 5 times 3, which is 15, over 6 times 3, which is 18. 16 take away 15 is 1, and this is over 18. Using this method is a bit more difficult, but it does save you having to cancel at the end. Here are some questions for you to try. Remember to give your answers in their simplest form, either as a mixed number or as a top-heavy fraction. Press pause and have a go. When you're ready, press play. Here are the answers. Now I want to add these two numbers together. You can see that these are both mixed numbers. To be able to add them together, it helps if I turn them into top-heavy fractions. So the first thing I want to do is express this number as a top-heavy fraction. To do this, I say 1 times 3 is 3 and add it to the top. That gives me 4, and that's still over 3. Then for this one, I say 2 times 4 is 8, and add that to the top gives me 11, and that's over 4. So what I've got is 4/3 plus 11/4. Now I need the denominators to be the same, so I'm going to multiply this one by 4 and this one by 3. 4 times 4 is 16, and 3 times 4 is 12. 11 times 3 is 33, and 4 times 3 is 12. Now I can add these. I get 49 over 12. I can't simplify this anymore, so this is the answer to this question. If you want to, though, you can change it to a mixed number. 12 goes into 49 4 times with a remainder of 1. I put this back over the 12. So my answer to this question is either 49 over 12 or 4 and 1/12. We subtract in a similar way. So I change this to a top-heavy fraction. 4 times 5 is 20, add 2 is 22. And I change this to a top-heavy fraction. 2 times 2 is 4, add 1 is 5. I'm subtracting these. So I'm going to multiply this by 2 and this by 5. So I get 44 over 10 minus 25 over 10. Taking away now gives me 19 over 10. This can't be simplified anymore. So this is the answer to this question. We can change it to a mixed number. 10 goes into 19 once with a remainder of 9. So the answer is either 19 over 10 or 1 9/10. Here's your final set of questions to try. Remember to give your answers in their simplest form, either as a top-heavy fraction or as a mixed number. Press pause and have a go. When you're ready, press play. Here are the answers. All of these questions here are asking you to do the same thing. So you might see a question saying 2/3 of 60, 2/3 times 60, or 60 times 2/3. So if I focus on the first one, I'm asked for 2/3 of 60. To do this, I'm going to work out 1/3 of 60. I do this by dividing by 3. I get 20. So 2/3 of 60 must be 2 of these 20s. So that's 40. Because this is the same question, the answer to this will be 40 as well, and so will the answer to this last one. To summarise, whenever you want to find a fraction of an amount, you divide the amount by the bottom of the fraction and then multiply by the top. Here's one for you to try. Press pause and have a go. When you're ready, press play. So the first thing we do is 40 divided by 8, and that's 5. We then get this 5 and multiply it by the 3. That gives us 15. So the answer to this question is 15. Here's a selection of questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Finally, here's an exam-style question for you. Press pause and have a go at it. When you're ready for the answer, press play. Here's the answer. At its most straightforward, multiplying fractions is just a case of multiplying the numerators together and multiplying the denominators together. So for this one, we have 2 times 5, which is 10, and 3 times 7, which is 21. All we need to do now is check to see whether this simplifies, and it doesn't, so this is the answer. This one is a bit more tricky. If we multiply the top numbers together, we get 36, and if we multiply the bottom numbers together, we get 180. Now this will simplify. 2 will go into both of these numbers. If I divide by 2, I get 18 over 90. I can do the same thing again, divide by 2 to get 9 over 45. Finally, I can see that 9 goes into both of these numbers. 9 goes into 9 once, and 9 goes into 45 5 times. So the final answer for this question is 1/5. Now there's actually a really clever method that you can use to get the answer for this question if you're good with numbers. You can actually cancel before you do the multiplication. You can cancel any top number with any bottom number. So if I look at this fraction here, I can see that 2 goes into 18 and 20. 2 goes into 18 9 times, and 2 goes into 20 10 times. Now if I look again, I can see that 2 goes into 2 over here, and 10 over here. 2 goes into 2 once, and it goes into 10 5 times. Looking again, and I can see that 9 goes into 9 here, and 9 here. 9 goes into 9 once, and 9 goes into 9 once. Now I've just got 1 times 1, which is 1, and 1 times 5, which is 5. So you can see here, I get the answer straight away. So to summarise, when multiplying fractions, you can either multiply first and then cancel, or cancel first and then multiply. Here's a question for you to try. Press pause and have a go. When you're ready, press play. When I do this type of question, I always like to use this method, because if you cancel first, you get lower numbers to multiply with. So looking at this one, I can see that 2 goes into 4 twice, and 2 goes into 14 7 times. Looking again, I can see that 7 goes into 7 once, and 7 goes into 7 once. Again, 2 goes into 2 once, and 2 goes into 8 4 times. Now I can multiply 1 times 1 is 1, and 4 times 1 is 4. So the answer is 1/4. Even if you do this question the other way, you should still get the answer 1/4. Here are some more questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In this question, I want to multiply a mixed number by a fraction. To do this, I need to turn the mixed number into a top-heavy fraction before I begin. So I've got 2 times 3, that's 6, and if I add it to the 2, I get 8. So I've got 8 over 3 multiplied by 6 over 7. Now I look to see if there's any cancellation. I can see that 3 goes into 3 once and 3 goes into 6 twice. Multiplying now gives me 8 times 2, which is 16, and 1 times 7, which is 7. This is the answer as a top-heavy fraction. You can change it to a mixed number if you want to. 7 goes into 16 twice with a remainder of 2, and this goes back over the 7. So the answer for this question is either 16 over 7 or 2 and 2/7. Here are some for you to try now. Press pause and have a go. When you're ready, press play. So for this one, we have 3 times 4, that's 12, add the 1 is 13. So I've got 13 over 4 multiplied by 8 over 9. I can see that 4 goes into 4 once and into 8 twice. Now I can multiply. 13 times 2 is 26, and 1 times 9 is 9. This is the answer as a top-heavy fraction. To change it to a mixed number, 9 goes into 26 twice with a remainder of 8. So we have either 26 over 9 or 2 and 8/9. For this one, 1 times 2 is 2, add 1 is 3, so I've got 3 over 2. 2 times 5 is 10, add 2 is 12, so I've got 12 over 5. 2 goes into 2 once and into 12 6 times. 3 times 6 is 18, and 1 times 5 is 5. So this is the answer as a top-heavy fraction. 5 goes into 18 3 times with a remainder of 3. This goes back over the 5, so our answer as a mixed number is 3 and 3/5. So the answer to the question is either 18 over 5 or 3 and 3/5. Here are some more for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This is asking me how many quarters are there in a half. If I draw myself a pizza and split it into halves, I can see that in this half I've got 2 quarters. So the answer to this must be 2. The question is, though, what method can I use to get this answer if the fractions aren't as easy? Well, there's a little trick. What we do is we keep this fraction as it is, flip this fraction so it turns into 4 over 1, and change the divide into a times. Now we can cancel here. 2 goes into 2 once, and it goes into 4 twice. Multiplying now, we get 1 times 2 is 2, and 1 times 1 is 1. And we know that 2 over 1 is the same as 2, so you can see that this method gives you the correct answer. So to summarise, if you want to divide fractions, flip the second one upside down and change the divide to a times. So for this much harder question, I definitely need to use this method. So remember, we keep the first fraction as it is, flip the second one, and change to a times. 2 goes into 2 once and into 8 4 times. 3 goes into 3 once and into 9 3 times. Now we can multiply. 1 times 3 is 3, and 1 times 4 is 4. So the answer to this question is 3 quarters. Here's one for you to try. Press pause and have a go. When you're ready, press play. So you should have kept this as 3/5, flipped this one to 3 over 1, and changed to a multiply. check for cancelling, there's actually nothing you can do here. So we've got 3 times 3, which is 9, and 5 times 1, which is 5. This is the right answer as a top-heavy fraction. If you want to change it to a mixed number, then 5 goes into 9 once, with a remainder of 4. So the answer to this question is either 9 over 5 or 1 4/5. This question looks a bit different, but we're still going to tackle it using the same kind of method. All we need to remember is that 6 can be written as 6 over 1. So this is how I put my first fraction. I change to a times and I flip the second fraction to 5 over 2. Now 2 goes into 2 once and it goes into 6 3 times. Multiplying gives me 3 times 5, which is 15, over 1 times 1, which is 1. And 15 over 1 is the same as 15. So the answer to this question is 15. So remember, if you see this kind of question, any whole number can be written over 1. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. If we come to a question with a mixed number and a fraction, we need to turn the mixed number into a top-heavy fraction. So we have 1 times 8, which is 8, plus 1 is 9. And we're dividing this by 3/4. Remember, we keep the first fraction as it is, change to a multiply, and flip the second fraction. Now 3 goes into 3 once and into 9 3 times, and 4 goes into 4 once and into 8 twice. Multiplying gives us 3 over 2. So the answer to this question is 3 over 2, or 1 1/2. Here's one for you to try. Press pause and have a go. When you're ready, press play. So 2 times 1 is 2, add 1 is 3. And 2 times 4 is 8, add 1 is 9. Keep the first one as it is, change to a multiply, and flip the second one. Now 3 goes into 3 once and into 9 3 times, and 2 goes into 2 once and into 4 twice. Multiplying gives us 2 over 3, so this is the answer that you should have got. Here are some more questions for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Finally, here's an exam-style question for you. Make sure you read it through carefully. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Chocolate bars are £1 each, and ice creams are £3 each. If I buy 1 chocolate bar, that's £1, and 2 ice creams is 2 times £3. Now, if I type this into my calculator, I want to get the answer £7, because that's obviously how much it's cost me. If you use a scientific calculator, you will get this answer. That's because the calculator knows not to do 1 add 2, which is 3, times 3 to get 9. Instead, it does 2 times 3 first, which is 6, and then does 1 add 6 to get 7. So, in a similar way here, if we buy 2 chocolate bars, that's 2 times 1, and 6 ice creams is 6 times 3. Now we know we want the answer £2 for the chocolate bars and £18 for the ice cream, so it's going to be £20. We need to do this bit first, that's 2, and this bit, which is 18. 2 plus 18 is 20. So you can see that when we have a calculation like this, we don't just do it in the order it appears, we do it in the order that makes sense. We have a way of remembering the correct order. We call it BODMAS, or sometimes BIDMAS. I'll explain the different letters here in a moment. Each of the letters stands for a mathematical operation, and we do them in this order. So B stands for brackets. Whenever you see brackets in a question, this part has to be done first, and brackets are often used to force you to do something first. The O and the I stand for other, or more correctly, indices. This means things like this here, or sometimes even square roots. D stands for division. We've got one of those here. M is multiplication. And then A and S are addition and subtraction, and these are always left until the end. So for this question, I do the brackets parts first. So that's here and here. So I've got 2 plus 3, that's 5, and 5 take away 2, that's 3. Those are multiplied together. 5 times 3 is 15, and this is the answer to this question. For this one, I need to do the other or index part first. So that leaves me with 4 times 5 squared, which is 25. 4 times 25 is 100, so the answer to this is 100. For this one, the division comes before the addition, so I do this part first. So I've got 12 plus 6 divided by 2, which is 3. The answer for this one is 15. And finally, for this one, the multiplications come before the addition. So I've got this and this before I add. So I've got 3 times 4, that's 12, and 5 times 2, that's 10, and these are added together to give me 22. So to summarise, if you're doing a question with more than one operation in it, and you're doing it without a calculator, then you need to refer to BODMAS or BIDMAS to work out which order to do it in. If you're using a scientific calculator, then you don't need to worry, because these are programmed to automatically use BODMAS or BIDMAS for you. Here are some questions for you to try without a calculator. Make sure you write down BODMAS or BIDMAS first so that you can refer to this to help you. Press pause and have a go. When you're ready, press play. Here are the answers. Reciprocal is one of those really difficult-looking mathematical words, but actually it just means 1 divided by the number. We can write it like this. So if I want to find the reciprocal of 2, I just need to write 1 divided by 2. I can leave my answer as this because this is a half. For 5, I've got 1 divided by 5, and again this one's fine to leave like this. For this one, I've got 1 divided by 0.1. I can't leave it like this because it looks messy, so I say, how many 0.1s in 1? That's 10. And for this last one, I've got 1 divided by a half. Again, this looks messy, but how many halves go into 1? 2. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now these questions look more difficult, but there's another definition of reciprocal which can help us with these. And that is that if you multiply a number by its reciprocal, you always get 1. To find out what I multiply this by to get 1, I can just flip it upside down. So the reciprocal of 2/3 is 3/2. Just to prove that this works, if I multiply them, I get 2 times 3, which is 6, over 3 times 2, which is 6, and 6 over 6 is definitely 1. So for the reciprocal of 4/5, I just flip it upside down and get 5 over 4. And in the same way for this one, I get 8 over 9. Here are some of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now here's a challenge for you. There's only one number in the whole world which doesn't have a reciprocal. Can you work out what it is? Press pause and have a go. When you think you've got the answer, press play. The answer is 0, because you can't do 1 divided by 0, and you can't multiply 0 by anything to get 1. There are two main types of hard calculator question. This is one type of question, and this is the second type. The difference is that these questions here are just a top divided by a bottom, whereas this type here is a top divided by a bottom and then square rooted. So starting with this question here, the first thing I do is work out the top part on my calculator. I get this. Now I need to work out the bottom part. I get this. To finish the question, I need to divide. And this is the answer for this question. In the same way, for this question, I start by working out the top part. I do this by typing square root 38.9 into my calculator. I write down all the figures that I get in my answer. Then I do the bottom part with the calculator. And I get this. To finish off, I need to divide. So this is the answer for this question here. Now this one is a little bit more tricky. I've got a square root sign on the top, but I want the square root of all of this. So the first thing I need to do is put some brackets in here. This will make sure that when I press the square root button, I find the square root of all of this. So for the top, I now type into the calculator square root, open bracket, 3.5 squared plus 2.85, close bracket, and then equals. I get this. Now I need to do the bottom. I get this. To finish off, I need to divide. And this is the answer that I get for this question. Now I'm moving on to the second type of question. Remember, in this one, we've still got a top and a bottom to divide, but after we've done this, we have to do the square root. So I start by working out 4.8 times 13.5. I get 64.8, and you can see that I've still got the square root sign because I haven't used the square root button yet. Now I'm going to do the bottom part here. I get this. Now I'm still not going to do the square root, I'm going to divide these first. You can see I've still got the square root sign, and then this number here is the answer to this division. To finish off, I now need to find the square root of this number. And this is the final answer. Here's a typical exam-style question for you to try now. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another one for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I hope you remembered that on this part here, you would need brackets like this. Here's your final question. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I hope you remembered on this part to leave the square root until the very end. To answer this question, I need to know that product means times, and the first few prime numbers are 2, 3, 5, 7, 11. I want to express 12 as the product of its prime factors. Because 12 is a nice small number, I can easily see that the answer is 2 times 2 times 3. These numbers are all prime numbers, and multiplying them together gives me 12. When I get a more difficult number like this, I can't just do it straight away in my head. I need to have a method. The first thing I do is write down the first few prime numbers. 2, 3, 5, 7, 11. I want to split the number 525 into prime numbers. So I write 525 and I show my first split. I need to find two numbers that multiply together to give me this number. Because it ends in a 5, I can see that 5 goes into it. And 5 goes into this number 105 times exactly. Now 5 is a prime number, so I put a circle around it. But 105 is not a prime number, so I split it again. It ends in 5 again, so 5 must go into it. And 5 goes into it 21 times. 5 is a prime number, so I circle it, but 21 is not prime, so I split it. 21 can be written as 3 times 7. 3 is a prime number, and so is 7. I've now finished splitting up my number into the prime factors. My answer is that 525 equals, and then I need to write these numbers in numerical order. So I've got 3 times 5 times 5 times 7. These are all prime numbers, and if I do this multiplication, I'll get 525. Sometimes the question might be phrased like this. The difference is that this time I'm asked for the product of powers of its prime factors. The working out will be exactly the same, but for the final answer, instead of writing this, I need to write 525 equals 3 times 5 squared times 7. I've simply written 5 times 5 as 5 to the power of 2 here. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Just be aware that when you're doing your working out, it doesn't have to look exactly the same as this. There are many different ways that you can split up the number 720, but you'll end up with the same numbers in the circles. For instance, many people might have split it up like this, but you can see that I've still got 1, 2, 3, 4 2s, 2 3s, and a 5. Here are some more for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This time the question doesn't ask for powers, so I've just written my answers like this. This is a more difficult question. It doesn't look like it's asking you to express 56 as the product of prime factors, but the clue is here. It does mention prime numbers. So to start with, I'm going to ignore this bit and just split up 56, which gives me this. I can now write that 56 is equal to 2 times 2 times 2 times 7. Looking at the actual question, I can see that I want a power of 2, so I'm going to write this as a product of powers of the prime factors. So I've got 2 to the power of 3 multiplied by 7. This now matches what I've got in the question. I'm asked to find the values of m and n. I can see that m is the power of 2, so that is 3. And n is the other number, and that's 7. This is the final answer. Here's one of those for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. In this question, I'm being asked to find the highest common factor of 12 and 15. I know that factors are the numbers which will go into a number, so I'm going to write the factors of 12 and the factors of 15. The factors of 12 are 1, 2, 3, 4, 6, and 12. And the factors of 15 are 1, 3, 5, and 15. I'm asked for the highest common factor. The common factors are 1 and 3, because these are the numbers that appear in both lists. The highest common factor is 3. So I can write highest common factor, or HCF, is 3. Here's another question. So for this one, I'm looking for the numbers that divide exactly into 18 and 45 without leaving a remainder. I get these lists of factors. The common factors are 1, 3, and 9. So the highest common factor is 9. Here are two for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now in this question, I'm dealing with larger numbers. I could do it in the same way and write out all the factors of 60 and all the factors of 96. But because the numbers are bigger, I might miss factors and it will also take me a long time to do. So instead, I'm going to use a different method, which looks like this. I'm going to find the product of prime factors for 60. And I'm going to do the same for 96. So I can now write that 60 equals 2 times 2 times 3 times 5, and 96 equals 2 times 2 times 2 times 2 times 2 times 3. Now the common factors are this 2 with this 2, this 2 with this 2, and this 3 with this 3. So I can now multiply the 2 by the 2 by the 3 here and get 12, and I have 2 times 2 times 3 here as well, which is also 12. So my final answer is that the highest common factor is 12. Here's one of those for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here are two more questions for you to try. This time you can choose which method you want to use for each question. Press pause and have a go. When you're ready, press play. Here are the answers. In question A, I had small numbers, so it made sense to use the first method. For question B, the numbers were much larger, so I used the second method. In this question, I'm asked to find the lowest common multiple of 3 and 5. I'm going to start by writing out some multiples of 3 and some multiples of 5. I'm going to do the first 10 multiples of 3. That's just the 3 times table. So I have 3, 6, 9, 27, 30. Remember, these aren't all the multiples of 3, it continues. I'm now going to write out the multiples of 5, but I'm going to stop when I find a number that's already in the 3 times table. So I have 5, 10, 15. That's already here, so that is the lowest common multiple of the two numbers. So the lowest common multiple, or LCM, is 15. So to summarise, here are the first few multiples of 3, and here are the first few multiples of 5, and I found that the lowest one that's common to both lists is 15, so that's the lowest common multiple. I would do this question in the same way. I'd start with the first 10 multiples of 8. I now write out the first few multiples of 12 until I find a number that already appears in this list. So the first multiple is 12, and the second multiple is 24, and that's here, look. So the lowest common multiple is 24. Here are 2 questions for you to do. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Now in this question, I'm dealing with larger numbers. I could write out the multiples of 60 and the multiples of 96 and find the lowest number that's in both lists, but that will take me ages and it will be difficult because of the numbers I've got. Instead, I need to use a method. In the same way as I found the highest common factor when I had larger numbers, I'm going to use a product of prime factors method. So I'm going to write the product of prime factors for 60 and the same for 96. So this is my product of primes for 60 and this is my product of primes for 96. There's actually a little formula to help you find the lowest common multiple. The lowest common multiple is the highest common factor multiplied by the rest of the numbers. I'll show you what this means now. For the highest common factor, we find the things that match in both lists. So I've got the 2 and the 2, the 2 and the 2, the 3 and the 3. So my highest common factor is 12. So the lowest common multiple equals the highest common factor, which is 12, multiplied by the rest of the numbers here that I haven't already underlined. So I need to multiply by 5, then by 2, another 2, and another 2. To find the answer, I need to work this out. So I've got 12 times 5, that's 60, times 2 is 120, times 2 is 240, times 2 is 480. So the lowest common multiple is 480. Here's one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. To get this, I needed to do this multiplication here. 4 times 2 is 8, times 2 is 16, times 5 is 80, times 3 is 240. I then needed to multiply 240 by 7. To do this, it's absolutely fine to do a little working out. 240 multiplied by 7 gives me 1,680. Here are 2 more questions for you to try. This time you can choose which method to use for each part. Press pause and have a go. When you're ready, press play. Here are the answers. This is a more difficult typical exam question. What you need to realise is that it's actually a lowest common multiple question in disguise. I'm told that buses to Amherst leave the bus station every 24 minutes and buses to Bingham leave the bus station every 20 minutes. I can see that a bus to Amherst and a bus to Bingham both leave at 9 a.m. So I know that the buses to Amherst leave at 9 a.m. and the buses to Bingham leave at 9 a.m. I want to know when the next time is that a bus to Weymouth and a bus to Bingham will both leave the station at the same time. The buses to Weymouth leave every 24 minutes, so the next one will be 9:24, then 9:48. Then to work out the next one, I need to add 24 onto 9:48. I can see that it's 12 minutes until 10 o'clock, so there'll be another 12 minutes after that, so that's 10:12. Then the next one will be 10:36. The next one after that would be 11 o'clock. And after that, we have 11:24. I'm going to stop here for now. The buses to Bingham leave every 20 minutes, so I'm now going to do the same thing, but for the buses to Bingham. I decided to stop here because I noticed that 11 o'clock appears in both lists. So the answer to the question is 11 a.m. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's your final question. Press pause and have a go at it. When you're ready for the answers, press play. Here are the answers. For part A, I found the lowest common multiple of 20 and 12, and I found that that was 60. 3 20s go into 60, so she must have bought 3 tins of sausages, and 5 12s go into 60, so she must have bought 5 packets of buns. If we draw a 1 by 1 square, we can see that the number of little squares it contains is 1. If we draw a 2 by 2 square, it contains 4 little squares. A 3 by 3 square will contain 9 little squares, and a 4 by 4 square will contain 16 little squares. These numbers, 1, 4, 9 and 16, are called square numbers. We can also write them like this. 1 squared equals 1, 2 squared equals 4, and so on. Now you're going to try calculating the first 12 square numbers. To help you, this is what your working out will look like. So for the first one, we've got 1 times 1, and we know that's 1. For the second one, 2 times 2 is 4. You need to finish off these. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. These are the first 12 square numbers, and it will be helpful to you if you can memorize them. Following on from that, we can also find the square root of any square number. This is the opposite of squaring it. So if I'm looking for the square root of 1, I'm trying to say to myself, what number do I multiply by itself to get 1? And the answer is 1. If I'm looking for the square root of 49, I'm saying, what number do I times by itself to get 49? And the answer is 7. We call 1 the square root of 1, and 7 the square root of 49. Now find the square roots of the rest of these numbers. Press pause and have a go. When you're ready, press play. Here are the answers. It will also be helpful to you if you can memorize these. Now, if we draw a 1 by 1 by 1 cube, we can see that this contains just one little cube. If we draw a 2 by 2 by 2 cube, we can see we've got 4 cubes on the bottom layer and 4 on the top layer, so this contains 8 little cubes. In a 3 by 3 by 3 cube, there are a total of 27 little cubes. And in a 4 by 4 by 4 cube, there are 64 little cubes. So these numbers, 1, 8, 27 and 64, are called cube numbers. And we can also write them like this: 1 cubed equals 1, 2 cubed equals 8, and so on. Now you're going to try calculating the first 5 cube numbers and the 10th cube number. To give you some help, your working out should look like this. For the first one, we know that 1 times 1 times 1 is 1. For the second one, 2 times 2 is 4, times by 2 again is 8. Now try to find the answers for the other questions. Press pause and have a go. When you're ready, press play. Here are the answers. We can also calculate the cube root of a number. The cube root sign looks like this. This is asking me to find the cube root of 1. So I need to know what number I multiplied by itself 3 times to get 1. And that is going to be 1. Here, I want the cube root of 1000. So I need to know what number I multiply by itself 3 times to make 1000. That's going to be 10. So the cube root of 1000 is 10. Here are some for you to try now. Calculate the cube roots of these numbers. Press pause and have a go. When you're ready, press play. Here are the answers. Finally, here's an exam-style question for you. Press pause and have a go. When you're ready, press play. Here are the answers. Sometimes in an exam question, you might see the word evaluate, or you might see the word calculate, or work out the value of. These phrases all mean the same thing. They're asking you to find the answer. So in this question, I want to work out the value of 5 squared. I know that 5 squared means 5 times 5. And 5 times 5 is 25. So to work out the value of 2 to the power of 4, this 4 is telling me that I've got 1, 2, 3, 4 2's all multiplied together. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the value of 2 to the power of 4 is 16. Another way of getting this answer is to say that 2 times 2 is 4, and 2 times 2 here is 4, so we've got 4 times 4, which is 16. For this one, we've got 3 times 3 times 3. So 3 times 3 is 9, multiply that by 3, and we get 27. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's your final question to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. You might have noticed that to get each number in the table, you always double the previous one. So for example, we can double the 4 to get 8, double the 8 to get 16, and double the 16 to get 32. This is because the fact that the powers go up by 1 each time mean that we're multiplying by an extra 2. This number here is the distance between Earth and Pluto in kilometres. And this number here is the radius of a hydrogen atom in centimetres. Now, looking at these two numbers, you can see that actually they're quite difficult to read because of all the zeros. Because of this, we have a special way of writing this type of number. A scientist would write this number like this, and they would write this number like this. We call this special way of writing very big or very small numbers standard form. You'll notice that we have a much easier number here, and that's what we call A. Then it's always times 10, and then we have a power, and that's what we've called B here. A is always a number between 1 and 10. So if you look here, you'll see 4.28 is between 1 and 10, and 5.3 is between 1 and 10. Now let's have a look how we actually write numbers in standard form. So here I've got the number 4,170,000. Remember, I need a number between 1 and 10 times 10 to the power of something. For this part here, I just take all the numbers before the zeros. So that's 417. And to make it a number between 1 and 10, I put a point after the first number. So I've got 4.17. I always have times 10. Now the only thing left is to work out what power of 10 I need. And I do this by imagining the decimal point in my number here. It was after the 4, so I've put it after the 4. I need to jump it along to the end of the number. So that's 1, 2, 3, 4, 5, 6. So the power is 6. Let's have a look at this one now. I've got the number 300,000 and I want to write it in standard form. So remember, the first thing I need is all of the numbers before the zeros. So that's 3. It's going to be times 10. And then I need to find the power of 10. And I do this by working out where the decimal point from this number is in this question. Now 3 is the same as 3.0, so the point is directly after it, so I can put it here. And now I've got to jump it to the end. 1, 2, 3, 4, 5. So the power of 10 is 5. So this number written in standard form is 3 times 10 to the power of 5. When we write a number in standard form, we don't change the value of the number at all. If you were actually going to work this out, 4.17 times 10 6 times, you would get this answer here. We've just written it in a form that's more convenient to read. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Let's look now at writing a small number in standard form. I have to do the same thing, have a number between 1 and 10, multiplied by 10, to a power. To get the number between 1 and 10, I look where the zeros stop, and I take these numbers, so I've got 6, 5. Again, we put a point after the first one. It's going to be times 10 because it always is. Now, to find the power, I get the point and put it into the number, and then I count backwards until I meet the other point. So I've got 1, 2, 3, 4, 5. Now, I went 5, but I need a way of saying that I went backwards, and I do that by saying it's minus 5. So this number in standard form is 6.5 times 10 to the power of minus 5. You should realise that because we move the point backwards, we're actually dividing by 10 5 times. And that's what this means. The minus 5 here tells us that actually we're dividing by 10 to the power of 5. I'm going to write this number in standard form now. So where the zeros finish, I've got the number 502. So I write that down first of all, and I put a point after the 5. Then I write times 10. Now I put this point into my number here, and I count back until I meet the other point. So that's 1, 2, 3, 4. Because I went backwards, remember it's minus 4. So this number in standard form is 5.02 times 10 to the power of minus 4. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now let's look at how we write numbers that are already in standard form as normal numbers. We need to reverse the process that we've just done. So first of all, I've got 3.6, so I'm going to write that down. I know that the decimal point needs to move 5 times to the right because it's being multiplied by 10 to the power of 5. So I go 1, 2, 3, 4, 5. Any empty archways I can fill in with zeros. And then I can write my number more neatly. So this number, as a normal number, is 360,000. And that's 360,000. Now let's look at this one. This time the power is negative, so when we move the decimal point we're going to move it to the left instead of the right. So I've got 4.17 and I've put it over here because I'm going to move the decimal point 8 places to the left. So that's 1, 2, 3, 4, 5, 6, 7, 8. That's where the new decimal point is. The archways can be filled in with zeros. And then we need a 0 before the point as well. So this number, as a normal number, is 0.000000417. Here are some questions for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Now this looks like a trick question. I'm being asked, is 47.4 times 10 to the power of 7 written in standard form? And at first glance it certainly does look as if it is. But remember, when we have standard form, we have to have a number that's between 1 and 10 times 10 to a power. And the problem here is that 47.4 is not a number between 1 and 10. So to write this in standard form, I would have to change the 47.4 to 4.74. This will still be times 10, but I've got another problem now. I can't just leave that as 7 if I've changed this number. To get 47.4 to 4.74, I've divided by 10. So I need to multiply by an extra 10 to even it out. So instead of 10 to the power of 7, I need 10 to the power of 8. Now if you find this difficult, there is actually another way of doing it. Let's write this out as a normal number. So we've got 47.4, and the times 10 to the power of 7 tells us to move the point 7 places to the right. 1, 2, 3, 4, 5, 6, 7. Fill in with zeros. So we have 474 with 6 zeros. Now to write this in standard form, I would write 4.74 times 10, put the point back in and then jump it to the end. 1, 2, 3, 4, 5, 6, 7, 8. So we know it's the power of 8. And you'll see that this matches this. This was a slightly quicker way of doing it, but this way will definitely get you the right answer. Now I want to write this number in standard form. It's not in standard form because this number is not between 1 and 10. So to make it a number between 1 and 10, I need to move the point 1 to the right so that I've got 2.4. What I've actually done is multiplied this number by 10. So to keep it even, I need to divide this by 10. So instead of 10 to the power of 4, this is 10 to the power of 3. So this is this number in standard form. If you don't like this method, you can always go the long way round. Write this out as a normal number, and then write the normal number in standard form. And you can see that we get the same answer. Here are some of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In this more difficult question, I'm being asked to work this out and to give my answer in standard form. I want to multiply this by this, and you can see that I've got multiplication signs all the way through, so I can do the multiplication in any order I like. So the first thing I'm going to do is get rid of the brackets. So I've got 3.1 times 10 to the power of 3 times 3.6 times 10 to the power of 4. Now I'm going to change the order slightly. So I'm going to write 3.1 times 3.6 times 10 to the power of 3 times 10 to the power of 4. Now I need to do 3.1 times 3.6, so I do this in my usual way as a long multiplication. So I get this. So this part here is 11.16. Now 10 to the power of 3 times 10 to the power of 4 is 10 to the power of 7. We're almost there now, except that this is not in standard form because this number is bigger than 10. So I need to divide this by 10 and multiply this by 10. So I get 1.116 times 10 to the power of 8. Now this is in standard form, but the question asks me for it to correct to one decimal place. So I need to round this to one decimal place, which is 1.1 times 10 to the power of 8. Here are some of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's a slightly more difficult question again. This time, I want to divide this by this. Because I've got this divide sign in the middle, I can't just get rid of the brackets this time, but I can write it as a fraction because I've got this divided by this. So I can write 7 times 10 to the power of 6 divided by 5 times 10 to the power of 4. Now I'm going to deal with the 7 divided by 5 first of all, and I'm going to do this as a bit of side working. I get 1.4, so 7 divided by 5 I can write as 1.4. Now I need to divide my powers of 10. I know when I divide, I subtract the indices, so 10 to the power of 6 divided by 10 to the power of 4 is 10 to the power of 2, because 6 take away 4 is 2. Now I just need to check that this is in standard form. This is a number between 1 and 10, so it is. So this is the answer to this question. Here is some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Everybody knows that a half is equal to 0.5. In the same way, every fraction has a decimal equivalent. I'm going to go through some that you need to know off by heart. All of these fractions are in common usage. A quarter is a half of a half. So it's half of 0.5, which is 0.25. 3/4 is 3 of these, so that's 0.75. Now a third is 0.333, etc. The 3 is recurring. We write this as 0.3 with a dot on the top to show that the 3 is recurring. Similarly, 2/3 is 0.6 recurring. We write this as 0.6 with a dot on the top. Once again, you need to make sure you know all of these conversions off by heart. You'll often be asked about tenths as well. These are really straightforward to convert to decimals. 1/10 is 1 divided by 10, which is 0.1. 2/10 is 2 divided by 10, which is 0.2. And this pattern continues all the way to 9/10, which is 0.9. 1/5 is another important fraction to know off by heart. 1/5 means 1 divided by 5, and this is 0.2. See if you can work out the decimal equivalents of these fractions now. Press pause and have a go. When you're ready, press play. We know that 1/5 is 0.2, so 2/5 is 2 of these, so it's going to be 0.4. 3/5 is 3 of them, so that's 0.6. And 4/5 is 4 of them, so that's 0.8. Remember, it will be really helpful if you can memorise these. Now, obviously, you don't want to have to memorise the decimal equivalent of every fraction in the world, so sometimes you need a method where you can work it out. You do this by dividing. If you've got a calculator, you simply put in 1 divided by 8. If you don't have a calculator, you need to set it up like this. So we have 1 divided by 8. Now 8 doesn't go into 1, so what I'm going to do is put a point and a 0 on the end here. Now 8 doesn't go into 1, but it does go into 10. 8 goes into 10 once with a remainder of 2. I put the 2 here and put another 0. 8 goes into 20 twice with a remainder of 4. I put the 4 here and put another 0. And then 8 goes into 40 5 times exactly. So 1/8 as a decimal is 0.125. So for this fraction, I'm doing 5 divided by 6. 6 doesn't go into 5, so I put 0.0. 6 doesn't go into 5, so I move the 5 along to make 50. 6 into 50 goes 8 times. That makes 48, so there's a remainder of 2. I put the 2 and put another 0. 6 into 20 goes 3 times. That makes 18, so there's another remainder of 2. I put that 2 and I put another 0. 6 into 20 goes 3 times. That's 18. There's another remainder of 2. Now, I spot here that I'm just going to continually get remainders of 2. So this is going to be 3 recurring. So my answer for 5/6 is 0.83 recurring. Here are some for you to try now. Press pause and have a go. When you're ready, press play. Here are the answers. I hope you realised that you should have known the first 2 off by heart, and you only need working out for the last one. Now I want to change these decimals into fractions. To do this, the numerator of the fraction, that's the top number, will be the number here. So for this one, it's 7. The denominator will always be a 1 with some zeros. And you find out how many zeros by counting the number of decimal places. This has 1 decimal place, so it will have 1 0. So 0.7 as a fraction is 7/10. The last thing to do is check to see whether it will simplify at all. This particular one won't, so this is the final answer. So for this one, the top number is 24, and the bottom number is a 1 with 2 zeros because we've got 2 decimal places. Now this one will simplify. I can halve both of these numbers to get 12 over 50, and then I can halve them again to get 6 over 25. So this is this decimal expressed as a fraction in its simplest form. For this one, the top number will be 125, and the bottom number will be 1 with 3 zeros because there's 3 decimal places. This one will simplify. I can divide by 5 to get 25 on the top and 200 on the bottom. And then I can see that 25 goes into both of these, once here and 8 times here. So this decimal, expressed as a fraction in its simplest form, is 1/8. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's an exam-style question for you to try now. Press pause and have a go. When you're ready, press play. For this question, you need to say that you know that a third is 0.3 recurring. So 5 1/3 is 5.3 recurring, not 5.3 as Sanjit claims. Finally, here's one more exam-style question for you. You can use a calculator for this one. Press pause and have a go. When you're ready, press play. Here's the answer. To get this, I knew that 3/5 was equal to 0.6. I worked out 11 divided by 20 with my calculator. I knew that 3/4 was 0.75, and I worked out 9 divided by 16 with my calculator. I then compared these to see which one was closest to this, and the answer is 9/16. Here are 2 signs that you might see when you're out shopping. Here, in the sale, everything is half price. And here in the sale, everything is 50% off. Now, these are obviously both good deals, and you should also realise that they're both exactly the same, because we know that a half is actually equal to 50%. And if we want to take this one step further, we also know that this is equal to 0.5. So what we have here is 3 different ways of writing exactly the same number. So we've already said that a half is 50% as a percentage, and as a decimal, it's 0.5. Let's have a look at some others that we need to know. You should know the fraction a quarter. This is 25%, and we can write that as a decimal as 0.25. Another fraction that you need to know by heart as a percentage and decimal is a third. As a percentage, this is 33.333 going on forever %. We can also write this as 33.3 recurring %. If we want to write it as a decimal, it's 0.333 going on forever, or 0.3 recurring. Now have a go at writing the percentage and decimal for these 2 fractions by yourself. You can use the work that I've already done to help you if you like. Press pause and have a go. When you're ready, press play. Now you should know 3/4 off by heart, but if you get stuck, you can always say it's 3 1/4. So 3 25% is 75%. And as a decimal, this would be 0.75. You can do this one in a similar way. We know that 1/3 is 33.3 recurring, so 2/3 must be double this, which is 66.6 recurring. Again, we can write it like this, 66.6 recurring. When we write it as a decimal, it's 0.666 going on forever, or 0.6 recurring. Here's a question for you now. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another question for you. You need to choose the odd one out in this list, and then really importantly, you need to give a reason for your answer. Press pause and have a go. When you're ready, press play. Here's the answer. We're now going to look at writing numbers in order. I'm asked to put these in order starting with the smallest, but the problem is that one's a percentage, two are fractions, and one of them is a decimal. So before I start, I'm going to write them all as decimals. So 70% as a decimal is 0.7. 3/4 as a decimal is 0.75. 0.6 is already a decimal, so I can leave it like that. And 2/3 as a decimal is 0.6 recurring. Now, to be able to compare these decimals, I really want them both to have two decimal places, like this one here. So I can put a 0 on the end of this one and a 0 on the end of this one. Now I can compare them. I can see that 0.60 is the smallest. That was 0.6, so that comes first. Then I've got 0.66. That was 2/3, so that comes next. Then I've got 0.70. That was 70%, so that comes next. And finally, I've got 0.75. That was 3/4, so that's the last number. So these numbers are now in order from smallest to largest. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. In this question, I'm being asked to calculate 32% of £864, and I'm allowed to use a calculator to do this. Percent means per 100, so 32% means 32 out of 100. Of in maths always means times, and the amount of money we've got is 864. We can now type this into our calculator, remembering that this line here means divide. So we type in 32 divided by 100 times by 864. The answer we get is £276.48. Here are some questions for you to try. Make sure you write your working out down exactly as I did before using your calculator. Press pause and have a go. When you're ready, press play. Here are the answers. Here's another one for you to try. This is an exam-style question. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here's your final question. Press pause and have a go. When you're ready, press play. Here's the answer. The first thing you needed to do was work out the cost of 4 packs of nails. So we've got 4 times £16.90, and that's £67.60. Look this up in the table. £67.60 is in this bracket here, so John's going to get 7.5% discount. We can now work out 7.5% of £67.60, and that gives us the answer, £5.07. In this question, I want to find 30% of £400, and I want to do it without using a calculator. Whenever you want to find a percentage of something without a calculator, always start by finding 10%. To find 10% of something, you always divide by 10. So dividing this by 10 gives me £40. You can now use this 10% as a building block to create the percentage that you're actually after. I want 30%. I multiply 10 by 3 to get 30, so I need to multiply this by 3 as well. I get £120, so 30% of £400 is £120. Now I'm being asked to find 15% of £280. We start in the same way with our building block of 10%. To find 10%, we divide by 10, so that's £28. Now to make 15%, I'm going to need a 5% as well. 5% is half of 10%, so I can halve this. That gives me £14. Now to get 15%, I want to add these two together. So I want to add these two results together as well. The answer I get is £42. So 15% of £280 is £42. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's an exam-style question for you now. In this question, you need to work out 15% of £30. But because this is a price reduction, you then need to take it away from £30 to work out the sale price of the dog basket. Press pause and have a go. When you're ready, press play. Here's the answer. Here's your final very difficult exam-style question. Make sure you take the time to read this one through carefully before you try it. Press pause and have a go. When you're ready for the answer, press play. I'm going to approach this question using a line-by-line method. Each month, Sue earns £620 basic pay, so she gets this even if she doesn't sell any phone or internet contracts. She earns 5% of the cost of all the phone contracts, so I need to work out 5% of £40. 10% is £4, so 5% is £2. She also earns 10% of the cost of all the internet contracts she sells, so I need to find 10% of £32. And that's £3.20. In April, she sold 26 phone contracts. Remember, for each phone contract she sells, she earns £2. So for 26 phone contracts, she's going to earn 26 times £2, and that's £52. She also sold 10 internet contracts. Remember, for each internet contract, she earns £3.20. So she's going to earn 10 times £3.20. And that's £32. So for the total amount, she gets her basic pay, that's £620. She gets £52 from the phone contracts. And she gets £32 from the internet contracts. This all adds up to £704. This is the final answer. I'm told that Sarah got 17 out of 23 in a maths test, and I want to write her mark as a percentage. I'm allowed to use a calculator to do this. I've got 17 out of 23, so I write that like this. To change something to a percentage, I need to multiply it by 100. I can now type this into my calculator, remembering that this line here means divide. So we've got 17 divided by 23 times 100. I get 73.91304348. The question asks me to give my answer to one decimal place. Rounding this off to one decimal place gives me 73.9, because after the 9 here, I've just got a 1, so I don't need to round it up. So the answer is 73.9%. So to summarise, when I want to change something to a percentage, I make a fraction and then multiply by 100. Here's one for you to do. Press pause and have a go. When you're ready for the answer, press play. So in this question, we have 13 girls out of 34 students. So we've got 13 out of 34, and we need to multiply this by 100. Using our calculator, we get 38.235,29412. We want to round this to one decimal place, so that's 38.2%. Here's another one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's your final question. Press pause and have a go. When you're ready, press play. We know that Janie scored 64 out of 75 in her exam, so we start by changing this to a percentage. We get 85.3 recurring percent. We now need to look this up in the table. She got over 84%, so she was in here, so she will have got a distinction. This is the final answer, and this is the working out. I'm being asked to express these as percentages. We know that percentage means out of 100. So for example, 30% is 30 out of 100. 15% is 15 out of 100, and so on. So here I've got 40 out of 50. To change it to a percentage, I need to make it out of 100. To get the 50 to 100, I can either multiply or divide, and I can see that I'm going to multiply by 2. So I do the same to the top, I multiply it by 2, and I get 80. So it's 80 out of 100, which is 80%. So for this one, I've got 14 out of 20, and I need to get that out of 100. To get 20 to 100, I multiply by 5. So I multiply the top by 5 as well. 14 multiplied by 5 is 70, so this one is 70%. Here, I've got 15 out of 25. If I multiply by 4, that gives me 60 out of 100, so that's 60%. Here, I've got 24 out of 40. Now I don't really know what to multiply by to get 40 to 100, so what I'm going to do first of all is halve it to give me 20. Halving this gives me 12. Now 20 I can easily get to 100 by multiplying by 5. So I'm going to multiply this by 5 as well and get 60. So this one is 60%. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Finally, here are some exam-style questions for you. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This is a headline that you would never see in a newspaper. because a newspaper wouldn't report this amount of money to this level of accuracy. Instead, it would probably say that the local man wins £2 million on the national lottery. Now, how did the newspaper get from this amount of money to this? They've rounded this to one significant figure. Let me show you how this works. Significant means important. When I'm looking at the digits of this number here, the 6 just represents £6. The 5 is £50, the 1 is £100, and as I move to the left, the digits are worth more and more. So the most important figure, the most significant one, is the one at the start. So when I'm rounding to one significant figure, I want to count one figure from the left and then draw a line down. I now need to look at the digit that comes immediately after the line. If it's a 5, a 6, a 7, an 8, or a 9, it's going to round this up. If it's a 4, a 3, a 2, a 1, or a 0, then this will stay the same. So the 9 will round the 1 up to a 2, and then I need to keep my number the same length by filling in with zeros. There are 6 digits here, so I'm going to need 6 zeros. So to one significant figure, this number here would be written as 2 million, and that's how the newspaper got their headline. So to answer this question, I draw a line after the first figure, and I look at this one here. It's a 4, so the 3 is going to stay as it is, and I fill in with the correct amount of zeros. I draw my line here and focus on the 8. That's going to round the 2 up to a 3, and then I fill in with the correct number of zeros. For the last one, I draw the line. The 5 is going to make the 7 round up to 8, and then I need the correct number of zeros. Here are some for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Now that we know how to round to one significant figure, it's actually no more difficult to round to different amounts of significant figures. Looking at this first one, I want 2 significant figures, so I count 2 figures from the left and draw my line. This number here is an 8, so it's going to make this round up, and it's going to go from 7.3 to 7.4. I fill in with zeros in the usual way. This question asks me for 3 significant figures, so I count 3 figures from the left and draw my line down. This 0 is not going to change this, so it's 4, 8, 8, and then 2 zeros. For this one, I want 2 figures, so I draw my line here. The 1 is not going to change this, so it will stay as 5, 9. Now this time, when I fill in with zeros, I've got to stop at the point. Putting 0.0 on the end would actually make this incorrect. For this one, I want 2 figures, so I draw the line here. This 6 is going to make this round up, so I'm going to go from 2.9 to 3.0. I fill in with 4 extra zeros. I want 3 figures on this one. The 8 is going to make this round up, so it's going to go to 4, 0, 0, and I fill in with zeros, but only as far as the point, so I just need 1 extra zero. Here are some of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now, when faced with this type of number, it's tempting to start counting your figures from here. But any zeros at the start of a number are actually just placeholders. They don't count as significant figures. The first significant figure is the first non-zero digit. So this is the first significant figure on this number. I only want 1 significant figure, so I put my line down here. This 7 tells me to round this up to 2, so I've got 0.2. This time, because we're after the decimal point, we don't need to fill in with any zeros at all. So for this one, again, I want one significant figure. I don't count this 0 or this 0. I start counting with this 4. The 8 tells me to round the 4 up to 5, so I've got 0.05, and I don't fill in with zeros because I'm after a point. Here, I want two figures. Don't count the 0, don't count the 0, start counting here. So 1, 2, draw the line. This 1 tells me to leave this as it is, so I've got 0.054. No zeros are needed on the end. I want three significant figures here. Don't count any of these zeros, start counting here. 1, 2, 3. The line goes here, and the 9 tells me to round up. So I have 0.0000178. For the last one, I want two figures. Don't count any of the zeros, count the 7 and the 9. The 5 tells me to round this up. So I have 0.0080. Because this 0 was part of my significant figures when I rounded, I need to leave it here. But I don't need to put any extra zeros on the end. So this is the answer to this question. Here are some of those for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's your final set of questions. You'll need a calculator to help you with these. Use the calculator to find the answer and then round your answer to two significant figures. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Before we look at estimation, you need to know how to answer questions like this. I've got to be honest with you, to answer this, all I do is 3 times 2, which is 6, and then I put the 4 zeros on the end. So the answer is 60,000. So for this one, we would have 7 times 6, which is 42, and we have 6 zeros to put on the end. Here are two for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. We're now going to look at division. These two questions are both asking you to do exactly the same thing. They're asking for 400 divided by 20. It's actually easier to work on a question that's set out like this. To do 400 divided by 20, I could divide top and bottom by 10 to get 40 divided by 2. I can then tell that the answer to this is 20. What I'm not going to show you is that you could just cross out this 0 and this 0, and then you've got 40 divided by 2, which is 20. Now we have these two questions, which are both asking me to do 70 divided by 0.02. Again, it's easier to actually work on this version. We don't like dividing by a decimal, so what we want to do is turn the decimal somehow into a whole number. There's two different ways to do this. The first way will be to multiply by 100, because if I multiply this number by 100, I will get 2. Now whatever I do to the bottom, I also need to do to the top as well. Multiplying this by 100 gives me 7,000. So I've now got 7,000 divided by 2, and the answer is 3,500. This is the answer to the original question. The other way to get this decimal to be a whole number would be to turn it into the number 1. So to do this, I'm going to start by multiplying by 10. If I multiply this by 10, I get 0.2, and if I multiply this by 10, I get 700. Now I can multiply this by 5 to make it the number 1. Multiplying this by 5 gives me 3,500. Now the answer to this, 3,500 divided by 1, is obviously 3,500. And again, this is the answer to the original question. You might be wondering why I've just shown you two methods to do the same question. But it really helps to be flexible in between these two methods. Sometimes when you're tackling a question, it's okay to get any whole number on the bottom. And sometimes it's better to turn the bottom into 1 because that might save you a difficult division. Here are two for you to try. You might want to turn this one into a fraction before you attempt to find the answer. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. For the second one, I've shown you both techniques for tackling the question. The answer in both cases is 800. Now that we know these two techniques, we can move on to exam-style questions on estimation. Whenever you're asked to estimate an answer, what you mustn't do is put the exact answer to the question. You've got to round the two numbers off and then carry out the calculation that this gives you. So I'm going to round this number to one significant figure. That's 70. And I'm going to round this number to one significant figure. That's 30. 7 times 3 is 21, and I've got two zeros. So my estimate for this question is this answer here, 2,100. In an exam, you get a mark for the rounding and a mark for the answer, so remember to show the working. Rounding this to one significant figure gives me 600, and rounding this to one figure gives me 90. 6 multiplied by 9 is 54, and I have three zeros. For this one, rounding to one figure gives me 20, and here I get 300. 2 times 3 is 6, and I've got three zeros. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This is another type of estimation question. We start in the same way by rounding the numbers to one significant figure. So rounding gives me this, and 600 divided by 5 is 120. If you find this division difficult, you can always set it out as a piece of side working, like this. So for this one, rounding gives me 900 divided by 30. This is the same as 90 divided by 3, so it's 30. Rounding this one gives me 70 divided by 0.5. Be careful when you're rounding off a number like this, and remember to do it to one significant figure. Now to answer this question, I can double this to get 1, and double the top as well to get 140. So the answer is 140. Rounding here gives me 600 divided by 0.2. If I multiply this by 10, I will get 2, and multiplying the top by 10 as well gives me 6,000. 6,000 divided by 2 is 3,000. Notice how I've been flexible with my methods for dividing by a decimal on these last two questions. Here are some questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here are two typical exam-style questions now. We're going to tackle them in the same way, by rounding each of the numbers to one significant figure first. So, for the 813, I get 800. For 19.8, I'll write 20. And for 97.6, I'll write 100. Now, I do the part on the top first. So that's 8 times 2, which is 16, with 3 zeros. And I want to divide this by 100. The answer to this is 160. So this is my estimate for this question. So rounding these numbers gives me 7 times 200 divided by 0.05. Again, I do the top bit first. 7 times 2 is 14, and I've got 2 zeros, and I'm dividing this by 0.05. I'm now going to multiply top and bottom by 10 to give me 14,000 divided by 0.5. I can double these now to give me 28,000 divided by 1, and the answer to this is 28,000. Here's your final set of questions to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. This is a typical exam-style question. I'm being asked to use this information here to write down the answers to these three questions. There are two main methods to do this. The first involves multiplying and dividing by powers of 10. I do this by comparing the question here with the question here. I can see that 83 has been multiplied by 10 to give 830. 251 has remained the same. So the answer to this question is going to be this answer multiplied by 10. So I get this. For this question, I can see that the 83 has stayed the same, but the 251 has been divided by 100 to give 2.51. That tells me that this answer here needs to be divided by 100. That gives me 208.33. Dividing is a little bit more difficult. I've got this number here, which matches this, and I've got this number here, which is the digits from this number. So I know that the answer must be something to do with the 83. Now this is an exact match, but this is 251 divided by 100. Now because we're dividing by a number that's 100 times smaller, the answer is going to get 100 times bigger. So the answer to this is 8,300. The second method involves estimation, and you can also use this to check your answers if you want. 830 is close to 800. 251 is in between 200 and 300, but it's slightly closer to 300. Now to get the answer to this, I do 8 times 3, which is 24, and then I put on the 4 zeros. So I need an answer using these digits, which is close to 240,000. The only way I'm going to get this is by putting an extra 0 on the end and giving myself 208,330. For the second question, 83 is close to 80, and 2.51 is close to 3. 8 times 3 is 24, and I have 1 0 to put on the end. So I need an answer that's as close to 240 as I can get, using exactly these digits in this order. I get 208.33. For the last one, this is close to 21,000, and 2.51 is close to 3. 21 divided by 3 is 7, so 21,000 divided by 3 is 7,000. So I need an answer using these digits that's as close to 7,000 as I can get, and my only option is to write 8,300. You might find that you want to use a mixture of these two methods. For example, a lot of people like to use the first method for the first two questions where we're multiplying, but prefer to use the estimation method when they're dividing. Here are some questions for you to try. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. I've shown you both methods. Finally, try these questions. Press pause and have a go. When you're ready for the answers, press play. Here are the answers, and again, I've shown you both methods. When we're multiplying something like this together, we simply add the powers. So this answer would be x to the power of 6. For this one, this x here is really x to the power of 1. So when we add the powers, we get x to the power of 7. For this one, this is t to the power of 1. So adding the powers gives us t to the power of 13. And we can write this algebraically like this. Whenever we're multiplying, we can add the powers together to get the final answer. When we're dividing, we subtract the powers. Remember, this is x to the power of 1, so we've got 5 take away 1, which is 4. For this one, we take away the powers and get x to the power of 4, and for this one, we would get x to the power of 6. Algebraically, we can write it like this. Whenever we're dividing, we subtract the powers to give the final answer. When we come to a harder question like this, we need to remember that this means x to the power of 4 times x to the power of 4 times x to the power of 4. Now, using our first rule, we can add the powers. 4 plus 4 plus 4 is 12, so this is x to the power of 12. There's a shortcut to get the 12. We can just do 4 times 3. So for this one, instead of writing it all out, I can do 2 times 7, which is 14. So the answer is x to the power of 14. We can show the shortcut algebraically like this. We multiply the two numbers together to give the final answer. So using my rules, I can do these questions very quickly now. Here I add the powers and get 5 to the power of 7. I add them here to get 7 to the power of 9. This is a divide, remember, so I subtract the powers and get 13 squared. And here I do the top and add the powers, that's 2 to the power of 14. I do the bottom and add the powers, remember that's a 1 there, so this is 2 to the power of 10. And then this is now a divide, so I subtract the powers to get 2 to the power of 4. Notice that I've left my answers like this, because in the question it says to leave your answers in index form. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now try these questions. Remember, this time you'll be using this rule. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This question is a little bit different. This time I'm being asked to work out the value of this. That means I've actually got to get a numerical answer. I'm not going to leave my answer in index form. There are two ways to do this. I can use my rule if I want to. So I multiply the powers to get 2 to the power of 6. And then I know that 2 to the power of 6 is this, which I can then work out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So this is the value of this. Or I could do it without using the rule. I would do the bit in the bracket first. That's 2 cubed, that's 2 times 2 times 2, which is 8. So I've got 8 squared. Now 8 squared is 8 times 8, which is 64. As you can see, it doesn't matter which method you use, you still get the same answer both ways, so just pick the one that you're most comfortable with. Here are some of those for you to do. Remember, this time you need to work out the actual values of these. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. You should spot that I've been flexible with my methods here. For the first one, I've done the bit in the brackets first and got 9 squared, and that's 81. For the second one, I've used the shortcut. 3 times 4 is 12, and 10 to the power of 12 will be a 1 followed by 12 zeros. Here are some more questions for you to try. This time, notice that you need to go back to leaving your answers in index form, and also that these are division questions. Press pause and have a go. When you're ready, press play. Here are the answers. Each of them is to the power of 0, because 6 take away 6 is 0, 2 take away 2 is 0, and x take away x is 0. I'm now going to show you something which I find really interesting. Here, we've got exactly the same questions, but this time I'm being asked to work out the values of them. 2 to the power of 6 is 64, and I want to divide this by 64. 64 divided by 64 is 1. Any number divided by itself is 1. Even here, because these two match, I'm dividing something by itself, so I definitely get 1. Now, if we look at the questions up here, we'll see that the answer to the first one was 2 to the power of 0. Remember, this is the same question, so 2 to the power of 0 must equal 1. In the same way, 7 to the power of 0 must equal 1. In fact, anything at all to the power of 0 equals 1. So here's your final set of questions now. Work out the values of these. Press pause and have a go. When you're ready for the answers, press play. Remember, we've just seen that anything in the world to the power of 0 is 1, so all of these answers are 1. Just out of interest, you'll often get one of these questions on the exam. It'll be worth 1 mark, and it's an easy mark to get if you can remember this fact. Here are 3 typical questions on lower and upper bounds. To explain how to do this, I'm just going to concentrate on the first one. I'm told that something has been measured as being 64 centimetres to the nearest centimetre, and I want to find the lower and upper bounds. What that means is I want to find the lowest number that rounds up to 64 and the highest number that would round down to 64. So the lowest number that still rounds up to 64 is 63.5. So the lower bound is 63.5 centimetres. The upper bound is not quite as straightforward. You might think that the highest number that still rounds down to 64 is 64.4. But if you think carefully, we could make this number a little bit bigger by putting a 9 on the end, and that would still round down to 64. But we could put another 9 on the end, and it would still round down, and another 9. In fact, we could put hundreds and hundreds of 9s on the end, and it would still round down to 64. What we need to do is think, what is the upper boundary for this number? And the upper boundary is 64.5 centimetres. Now these two numbers are the lower and upper bounds. There is actually quite a nice way of getting these two answers. Let me show you. I'm told that it's been measured to the nearest centimetre. Remember, this means the nearest 1 centimetre. What I need to do is divide this by 2. And that gives me 0.5 centimetres. To get the upper bound, I add on 0.5. And to get the lower bound, I subtract 0.5. So the upper bound is 64.5 centimetres, and the lower bound is 63.5 centimetres. Let's see this method in action for a couple more questions now. So here we have 45 centimetres measured to the nearest 5 centimetres. So the first thing I do is divide the 5 by 2 to get 2.5 centimetres. For the upper bound, I add this on to the 45, and for the lower bound, I subtract it from the 45. So the upper bound is 47.5 centimetres, and the lower bound is 42.5 centimetres. For this one, it's measured to the nearest 10, so I start by dividing that by 2 to get 5 centimetres. For the upper bound, I add it on, and for the lower bound, I subtract it. So the upper bound is 255 centimetres, and the lower bound is 245 centimetres. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. These questions are more difficult, but we can still use the same technique. We're told here that this has been measured to the nearest 1/10 of a centimetre. 1/10 of a centimetre is 0.1 centimetres, so this is what I divide by 2, and I get 0.05 centimetres. Now that I've got this, I can get my answers in the usual way. This is the upper bound and the lower bound. In this question, I'm told that it's correct to 1 decimal place. Now 1 decimal place is the same as 1/10, so my working is going to be the same as this. So I've got 0.1 divided by 2, which is 0.05 centimetres. Now I can find my upper and lower bounds. And I get that the upper bound is 9.45 and the lower bound is 9.35. For the last one, I'm told that this is correct to 2 decimal places. That's the same as 1/100th of a centimetre. So I've got 0.01 divided by 2. And that is 0.005 centimetres. Now I can find my upper and lower bounds. This is the upper bound and this is the lower bound. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This is a typical exam-style question. I'm being told that I've got the length and the width of a rectangle measured to the nearest 1/10 of a centimetre, and I want to calculate the lower bound for the area. This tells me that this is a bounds question. The most common mistake that people make is to try and find the area of the rectangle using these two measurements, and then find a lower bound for this number. This isn't the right way to go about this question. Instead, because I'm told the length and the width to the nearest tenth of a centimetre, I'm going to find the lower bound for the length and the lower bound for the width, and then use this to calculate the area. So I know that the area is the length multiplied by the width. I'm told that the length is 36.7, correct to the nearest tenth of a centimetre. Remember, a tenth of a centimetre looks like this, and we halve it. That gives us 0.05 centimetres. To find the lower bound, we subtract this from this number. So the lower bound is 36.65 centimetres. This is the number we're going to use for our length down here. Now I need to do the same thing for the width. So for this number here, the lower bound is 24.25 centimetres. This is the number I'm going to use in my calculation. Now, using a calculator, I can get the answer to this, and it's 888.7625 centimetres squared. This is the lower bound for the area of the rectangle. Here's one of those for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. This time we were looking for the upper bound for the area, so we needed to find the upper bound for this length and the upper bound for the width, and then multiply them together. Here's your final question. You'll find it helpful on this one to draw your own diagram. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. These are the basic laws of indices. As you know, when we're multiplying, we add the powers. When we're dividing, we subtract the powers. And when it looks like this, we multiply the powers. So if I want to simplify this, I could do it by subtracting the powers because I'm dividing. 2 take away 5 is minus 3, so this is x to the power of minus 3. However, I could also set the question out like this. Once I've done this, I can then cancel this x with this x, and this x with this x. Now that gives me 1 times 1, which is 1, over 1 times 1 times x times x times x, which is x cubed. So we can now see that x to the power of minus 3 must be the same as 1 over x cubed. In the same way as this, if we had x to the power of minus 5, we would know that that's 1 over x to the power of 5. And we can generalise this result like this. X to the power of minus a is 1 over x to the power of a. So we began this clip with these 3 laws of indices. And we can now add our 4th law to that. Now I'm going to look at these 2 typical exam-style questions. I'm asked to find the value of 2 to the power of minus 5. I already know that that's 1 over 2 to the power of 5. So that's 1 over 2 times 2 times 2 times 2 times 2. So that's 1 over 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the value of 2 to the power of minus 5 is 1 over 32. And I leave my answer like this. I don't change it to a decimal. So for this one, 3 to the power of minus 2 is going to be 1 over 3 to the power of 2. And I'm multiplying that by 4 to the power of minus 1, which is 1 over 4 to the power of 1, which is just 4. So that's 1 over 3 times 3 times 1 over 4. Now this is 1 over 9, and I'm multiplying by 1 over 4. So multiplying the numerators gives me 1, and multiplying the denominators gives me 36. This is the answer, and again I leave it in this form, I don't change it to a decimal. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here are some more questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. This question, which asks for an error interval, is actually a bounds question in disguise. I'm told that this number has been rounded to 1 decimal place. The first thing I need to do is find the upper and lower bounds for this number. If it's rounded to 1 decimal place, then that's to the nearest 0.1. So I start by dividing that by 2, and I get 0.05. Now the number was 3.6, so to find the upper bound I add on 0.05, and for the lower bound I subtract 0.05. So I get 3.65 and 3.55. Now to write the error interval, we start with the letter we've been given, that's x. We know it's got to be between the upper and lower bounds, so it's got to be between 3.55 and 3.65. Now we want some symbols in here. We use the less than or equal to symbol here and the less than symbol here. The important thing is to realise that this one has the equal to part, but this one doesn't. So what we're saying is that x can be any number as long as it's greater than or equal to 3.55 and it's less than 3.65. We don't have the equal sign on here because if x was equal to 3.65, then that would round up to 3.7, not down to 3.6. Just out of interest, some people forget which way the signs go. A nice way to remember it is that they mirror this here, so they always point this way. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another one for you to try. Notice this time that the number has been rounded to 2 decimal places. That means it's been rounded to the nearest 0.01. Press pause and have a go. When you're ready, press play. Here's the answer. This is a slightly different question. I'm told that the number has been rounded to 2 significant figures. So 2 significant figures means that the cut-off point is here. So for this number, it's been rounded to the nearest 10. So 10 divided by 2 is 5. So for the upper bound, I add on 5, and for the lower bound, I subtract 5. So I get 565 and 555. So remember, for the error interval, we have our letter, our lower bound, our upper bound. Our signs always go this way, and this one has the equal to. So Z is greater than or equal to 555, but less than 565. Here's one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. I hope you notice that this time, even though the number is rounded to 2 significant figures, that's equivalent to rounding to the nearest 100. Here's another one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. In this clip, we're going to be looking at forming mathematical arguments. Stacey says if you divide any multiple of 10 by 2, the answer always ends in a 5. We want to find out is she correct and write down a calculation to support our answer. So the multiples of 10 are things like 10, 20, 30. So if I start with 10, 10 divided by 2 is 5, so that does end in a 5, so it looks like she's correct. But I can't just go for one, let's try another one. 20 is the next multiple of 10. If I divide that by 2, I get 10, and that definitely doesn't end in a 5. So she's not correct, and the calculation to support my answer is this one here. We call this a counter example, and we only need to find one of them to prove that Stacey is not correct. Here's a question for you to try. Press pause and have a go. When you're ready, press play. Here's the example I've chosen to show that Cat is not correct. 2 is a prime number, so is 3, and they add together to give an odd number. You might not necessarily have chosen the same numbers as me, but you should have done 2 plus any other prime number. This will always give you an odd number, so this shows that Cat is not correct. Here's another question for you. This time, once you've decided whether Dave is correct or not, you need to write a brief explanation. Press pause and have a go. When you're ready, press play. Here's the answer. Dave is not correct, and he's not correct because 2 is a prime number, and 2 squared is 4. 4 is even, not odd. Here's another one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. I found 3 numbers between 160 and 230 that have 25 as a factor, so Cara is definitely wrong. Here's a slightly different type of question now. I'm told that P is an odd number. Q is an even number. I need to explain why P plus Q plus 1 is always an even number. Now, it's quite tempting to say that P is an odd number, let's say 1, and Q is an even number, let's say 2, and show that this works. But we have to prove that it's always even. So I know that P is odd, and Q is even. And I also know that any odd number plus any even number will give me an odd number. So P plus Q is definitely odd. Now, any odd number plus 1 is definitely even. So P plus Q, which is an odd number, remember, plus 1 is definitely an even number. Here's a question for you to try now. Press pause and have a go. When you're ready, press play. Here are the answers. This number is 0.3 recurring. To save us having to write out all of these 3's, it can be written as 0.3 with a dot on top of the 3. The dot shows which digit is recurring. So here we have 0.42 recurring. We could write this as 0.42 with a dot on top of the 4 and a dot on top of the 2 to show that these 2 digits both recur. For this one, we have 0.123 and the 1, 2, 3 recurs. This time we can put a dot on the 1 and a dot on the 3 to say that this whole section recurs. For this last number, we would write 0.428571 and we would put a dot on the 4 and on the 1 to show that this is the recurring section. To write a recurring decimal as an exact fraction, we just need to put the digits over the correct amount of 9's. So for this one, we've got one digit that recurs, that's the 2. Because we've only got one recurring digit, we only need 1 9. So 0.2 recurring is 2/9. In this one, I've got two digits that are recurring. That's 2, 1. So because I've got two digits recurring, I put it over two nines. So I have 21/99. Now both of these numbers are in the 3 times table, so I can divide by 3 to give me 7/33. So 0.21 recurring as an exact fraction is 21/99, and in its simplest form, it's actually 7/33. For this one, I have 3 recurring digits, so I write 234 over 3 nines, 999. I can see that 3 goes into both of these numbers, so I need to divide by 3. I get 78 over 333. Now 3 goes into both of these again. I get 26 over 111. This is this recurring decimal written as an exact fraction in its simplest form. In an exam, you would get a mark for the unsimplified form and an extra mark for the fully simplified version. Here are 3 for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. These are our 4 basic laws of indices. When we're multiplying, we add the powers. When we divide, we subtract the powers. When it looks like this, we multiply the powers. And if we've got x to the power of negative something, then it's 1 over x to the power of that something. In this clip, we're going to be looking at the 5th rule of indices, which is fractional indices. To introduce fractional indices, let's look at what happens if we've got x to the power of a half multiplied by x to the power of a half. Now, at the moment, I don't know what x to the power of a half actually means, but I can use my first rule of indices to find out. When I'm multiplying, I add the powers, and a half plus a half is 1, so this is x to the power of 1, which is just x. So I've got something times by itself, and that's giving me x. Well, I know that if I multiply something by itself and I get x, then the something must be the square root of x. So x to the power of a half is actually the square root of x. In a similar way, what if I had x to the power of a third times x to the power of a third times x to the power of a third? Well, again, I can add the powers. A third plus a third plus a third is 1. So again, we know that this is just x. So we're multiplying the same thing together 3 times and getting x. That tells us that x to the power of a third must be the cube root of x. And we show that like this with a little 3 outside our root symbol. When we've got a square root, we could put a little 2 here, but you don't have to. A root sign like this without a number always means square root. If you want it to be something other than square root, you do need to put the little number here. So here is what we've just found out. X to the power of a half is the square root of x, and x to the power of a third is the cube root of x. Now let's take this one stage further. If I wanted to square x to the power of a third, then I would be squaring the cube root of x. Now we know that when we have this, we multiply the powers together, and a third times 2 is 2/3. So that gives us x to the power of 2/3 is the cube root of x raised to the power of 2. So we now have this result, and we can generalise this to this, where we have x to the power of a over b. That gives us the bth root of x. I'm not sure that bth root is really an English word, but you know what I mean. To the power of a. So the number on the bottom gives you the root, and the number on the top gives you the power. So now I'm going to use this rule to help me answer these questions. So for this one here, I want the cube root of 64 to the power of 1. So that's actually just the cube root of 64. Now the cube root of 64 is what I multiply by itself 3 times to make 64, and that's 4. So this is the answer to this question. For this one here, I want the 4th root of 81 to the power of 3. Now the 4th root of 81 is what I multiply by itself 4 times to get 81, and that's 3. So this is 3 to the power of 3. And 3 to the power of 3 is 3 times 3 times 3, which is 27. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try. Part A is reasonably similar to the work we've just been doing, but Part B is much more difficult. You'll notice that Part B starts with the word hence. That means that they're trying to ask you to use Part A to help you with Part B. Press pause and have a go. When you're ready, press play. Here's what your answer for Part A should look like. Now for Part B, I'm asked to find the value of x if 4 to the power of x is equal to 8 to the power of 6. Now I'm going to use this from Part A to help me. I know that 4 to the power of 3 over 2 is equal to 8. So, if I now want 8 to the power of 6, that's going to be 4 to the power of 3 over 2 to the power of 6. Now remember, when we have this situation, we can multiply these numbers here. So that gives me 4, 3 times 6 is 18, and that's over 2. And that's equal to 8 to the power of 6. Now 18 over 2 is actually 9, so that's 4 to the power of 9, and that's equal to 8 to the power of 6. So I found that x is actually 9. So x equals 9. Now, to allow us to go further into fractional indices, we're going to combine this law with this one that we've just been working with. It's not too big of a step to realise that we can have minus a over b, and that will give us this, combining the 1 over from here with this from here. So we now have this new rule. Now let's use this rule to answer these two questions. I want to evaluate 64 to the power of minus a half. The first thing I know is that the minus means it's 1 over. So we've got 1 over 64 to the power of a half. Now 64 to the power of a half means the square root of 64. So I've got 1 over the square root of 64. And the square root of 64 is 8. So that's 1 over 8. So this is actually 1/8. For this one again, the minus tells me it's 1 over. So I've got 1 over 125 to the power of 2/3. Now here, the bottom number gives me the root, so I've got the cube root of 125. And that's to the power of the top number, which is 2. And remember, it's 1 over that. Now the cube root of 125 is 5, so that's 1 over 5 squared. And 5 squared is 25, so that's 1 over 25. So the answer to this is 1/25. Here are some for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Now this is a much more difficult question. To be able to answer this, the first thing I need to do is find a link between the number 32 and the number 16 that's to do with powers. It's no good just noticing that 32 is double 16 because that's not a power. But I do notice that 32 is 2 to the power of 5, and that's to the power of x, and 16 is 2 to the power of 4. Now I can rewrite this as 2 to the power of 5x, because when I have this situation, I multiply the powers. And I can rewrite this as 2 to the power of minus 4, because 1 over 2 to the power of 4 means 2 to the power of minus 4. Now I've got a link between the two. They're both in powers of 2, so I know that 5x must be equal to minus 4. It's one small step from here to say that x is minus 4 over 5, and this is the answer to the question. Now here's your final really difficult question. Press pause and have a go. When you're ready, press play. Here's the answer. I'm being asked to prove algebraically that 0.7 recurring equals 7/9. There's a set way of doing this. We say we're going to let x equal this number here. That's 0.7 recurring, and I'm going to write a few 7s in. Now, because there's only one number recurring, I'm going to multiply this by 10. So I get 10x equals, and if I multiply this by 10, I get 7.77777 going on. Now I'm going to subtract this line from this line. So 10x take away x gives me 9x, and 7.77777 take away 0.77777 is just going to give me 7, because all of these 7s here will go and I'll be left with 7 take away 0. Now from this line, it's just a quick rearrangement to see that x is equal to 7 divided by 9. So I've now proved that 0.7 recurring, this number here, is equal to 7/9. Here's one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. You will initially prove that x is equal to 6/9, which you can then cancel to 2/3. Here's a slightly different question. We start in the same way. Let x equal this number here. Now these two dots tell me that the 2 and the 7 are recurring, so we have 2, 7, 2, 7, 2, 7, and so on. Now because we've got two numbers recurring, instead of multiplying by 10, we multiply by 100. At this stage, I'd like you to take over. Continue in the same way as you've done the other questions. Press pause and have a go. When you're ready, press play. You should have continued like this. When you subtract, you get 99x equals 27, which you rearrange to get 27 over 99, and then cancel to get 3 over 11. Now remember, whenever we have one recurring decimal, we multiply by 10 in our proof, and whenever we have two recurring decimals, we multiply by 100. Now try these two questions. Press pause and have a go. When you're ready, press play. Here are the answers. Now in this question, I'm asked to express the recurring decimal 0.284 with the 84 recurring as a fraction in its simplest form. I'm not really asked to prove it, but there isn't really a shortcut to get to the answer without doing the proof. So let's have a look how this works. We're going to say x is equal to this number here. So that's 0.2848484 and so on. Now I've got two numbers that are recurring, so I'm going to multiply by 100. So I have 100x equals 28.484848, and so on. Now I'm still going to take this line away from this line. So I've got x equals 0.284848, and so on. Now 100x take away x is 99x. Now to subtract this from this, notice how from this point onwards the numbers have all lined up. So these will disappear to 0 and I can just subtract this. 28.4 take away 0.2 is 28.2. Now I don't want to mix up decimals with fractions, so I'm going to multiply now by 10 to get rid of the decimal here. So if I multiply by 10, I get 990x equals 282. Now I can make a fraction. X is 282 over 990. Now I can cancel this. First of all, I'm going to divide top and bottom by 2, so I get 141 over 495. And this cancels again. I can divide top and bottom both by 3 to give me 47 over 165. So this decimal, 0.284, with the 8 and the 4 recurring, is equal to 47 over 165, and this is a fraction in its simplest form. Here's one of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. I want to find the upper and lower bounds for this number, which has been measured to two significant figures. So 760 to two significant figures means that my cutoff is here, so it's been measured to the nearest 10. If I get that 10 and half it, I get 5. So to calculate the upper bound, I add 5 onto the 760 and get 765. And for the lower bound, I subtract 5 from the 760 and get 755. So this is my upper bound and this is my lower bound. I want to do the same thing for this number, which is measured to two decimal places. Now the first decimal place is this one here, the tenths, and the second decimal place is this one here, the hundredths. So this has been measured to the nearest hundredth, which is 0.01. If I divide that by 2, I get 0.005. So to find the upper bound, I add 0.005 onto this number and get 15.675. And to find the lower bound, I subtract it to get 15.665. So this is the upper bound and this is the lower bound. Here are two for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now we're going to increase the level of difficulty a little bit. In this question, we're going to have to work out some bounds and then use them to do a calculation. So we need to work out which bounds to actually use. You'll see what I mean as I go through it. So Sue drives her car a distance of 320 miles, correct to two significant figures. So I'm going to find the upper and lower bounds for this first. So 320 correct to two significant figures means that this number is to the nearest 10. Half of that is 5, so I'm going to add on 5 and subtract 5 to get the upper and lower bounds. That's 325 and 315. Now I'm told her car uses 49 litres of petrol, correct to the nearest litre. So 1 litre divided by 2 is half a litre. So I'm going to add on a half and take away a half to get the upper and lower bounds for this number. So I get 49.5 and 48.5. Now what I want to work out is in miles per litre, so that means I've got to divide the miles by the litres, and I need to find the maximum value. So for the maximum value, I want the largest possible miles, so that's the upper bound of the miles, and I want to divide that by the lowest possible amount of petrol, so that's the lower bound for the petrol. So that gives me 325 divided by 48.5. Using a calculator and rounding to one decimal place, I get the answer 6.7 miles per litre. Here's a question for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Just out of interest, 50 crates is right on the limit of the breaking strain, so you might also write the answer 49 crates, and this is also an acceptable answer. Here's another one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. To calculate this, you need to work out your bounds first of all. Then, to be completely safe, you want to pretend that the boxes are as heavy as they can be, so you take the maximum, the upper bounds for the boxes. There's 3 of these, that gives me this, and 7 of these, that gives me this, and I then add them together. Now, again, for safety's sake, we want to pretend that the safe load is the lowest possible value it can be. So we need to see whether this is more or less than this number here. Because it's more than it, the lift cannot safely carry the boxes. Now, this is a very particular type of question. You can spot this kind of question by looking out for these words here. We're looking for an appropriate degree of accuracy. This means that you've got to do something very specific when you round off these numbers. It's really tempting to say, well, the lower bound is this, and the upper bound is this, so I'm just going to go for one decimal place and say it's 1.7. But because it says this, you've actually got to do a bit more work. You need to find the most accurate answer where both the lower and upper bounds will agree. I always start from the left. If I look at the first digit of each number and say that I'm going to cut the numbers off here, they're both 1, and with a 7 coming after both of them, they would both round to 2. But we can probably be more accurate than that. If I look at the next digit along, this is 1.7, and so is this. Because of the 1 and the 2 here, they would both stay as 1.7, so they both match. But I can probably be more accurate than that. If I go one more digit along and make my cutoff point here, I can see this is 1.71, but with the 6 here, that would be 1.72, and this is 1.72 as well. So they both match at this point. If I go one more digit along, I can see that this number here is 1.717 when I round it off, and this one is 1.725. So this is the point where they're different. So what I need to do is go back one place. And that makes my cutoff point here because both of these numbers will round to 1.72. So this is my answer. To finish, I need to explain why this answer is appropriate, and I always write the same thing. The upper and lower bounds both agree to this number of figures. Here's one of those for you to try now. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here's another one for you to try. Press pause and have a go. When you're ready, press play. Here's the answer. Now here's a slightly more difficult question for you. In this one, you've got to work out your upper and lower bound for M before considering the suitable degree of accuracy. Press pause and have a go. When you're ready, press play. Here's the answer. To get this, I calculated the lower bound for m and the upper bound for m, and they both round to 0.229. You need to be able to identify whether or not a number is a surd. Let's have a look at this number. 16 is a square number. We know that it's 4 times 4. So the square root of 16 is 4, and that means that this is not a surd. If we look at this one now, 15 is not a square number. If you get a calculator and do the square root of 15, you'll find you get a decimal that goes on forever. That tells me that root 15 is a surd. Looking at this one, you should instantly recognise that 25 is a square number. So root 25 is 5, and that is not a surd. So to summarise, if we can't remove the square root sign, then we have a surd. Now here are some for you to try. Try to identify whether these numbers are surds or not. Press pause and have a go. When you're ready, press play. So for this one, 24 is not a square number, so this is a surd. Also, if you put this into a calculator, you'll get a decimal that goes on forever. For this one, 1 is a square number, so this one is not a surd because the square root of 1 is 1. For this one, 2 is not a square number, so this one is a surd. Here are some more for you. Try to identify whether these are surds or not. You can use a calculator to help you with these. Press pause and have a go. When you're ready, press play. Here are the answers. Now the first rule we have to be aware of with surds is this one here. Let me explain it using some numbers. If I have the square root of 9 times by the square root of 9, I know that this is 3, and this is also 3, and 3 times 3 is 9, so the answer to this is 9. We can see that root 9 times root 9 just gives us 9, so we don't actually need to do this line of working out. In the same way, if I have root 13 times root 13, I know that the answer is just going to be 13. If I have root 2 times root 2 times root 5 times root 5, then I know that root 2 times root 2 is 2, and root 5 times root 5 is 5, and I can multiply these together. 2 times 5 is 10, so the answer to this is 10. If I have root 6 times root 6 times root 6, then I know that root 6 times root 6 is 6, and I've still got this times root 6 on the end. Now, in the same way as when we're doing algebra, I can actually get rid of this times sign and just have 6 root 6. Here are some questions for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. Notice that for part E, I started by rearranging this. So I put the two root 2's together and the root 11's together, and then put the root 3 on the end. I know that this gives me 2, this gives me 11, and I've still got the root 3. 2 times 11 is 22, so I end up with the answer 22 root 3. Now the next rule of surds you need to be aware of is this one here. Again, I'm going to explain this using some numbers. Let's say I was asked to simplify root 12. Now using this here, I know that root 12 can be written as root 4 times 3, because 12 is 4 times 3. Using this part now, I know that this is root 4 times root 3. Now I know that root 4 is 2. Remember, you can get rid of the times sign, and then I've just got the root 3 on the end. This is the simplest form of root 12, because I've got the smallest possible number underneath the root sign. I'm now going to try and simplify root 18 using a similar method. I can see that 18 is 6 times 3, so this must be root 6 times 3. That makes it root 6 times root 3. Now this isn't really going anywhere, so I'm going to try again. I'm going to have root 18, but this time, instead of 6 times 3, I'm going to spot that 18 is 9 times 2, so I've got root 9 times 2. Now this is root 9 times root 2, and this time root 9 is 3, so this is 3 root 2. This is the fully simplified version of root 18. The thing to notice here is that when you're splitting up your number, look for the biggest square number that goes into it, and that will help you simplify it very quickly. Just out of interest, if I'd have carried on along this path and written root 6 as root 2 root 3, because 6 is 2 times 3, and then have the times root 3 on the end, you'll notice that I've got root 3 times root 3, which is 3, and I've got a root 2 as well. So I still get 3 root 2, but in a more roundabout way. Let's look at simplifying one more. I'm going to look at root 72. Now remember, the fastest way to do it is to look for the biggest square number that goes into 72. I can see that 72 is 36 times 2. Now that's root 36 times root 2. 36 is a square number, so root 36 is 6, so this is 6 root 2. Now if you didn't spot that 36 goes into 72, you might have thought that the biggest square number is 9, because 72 is 9 times 8. So this gives me root 9 times root 8. Now root 9 is 3, so this is 3 root 8. Now some people might stop here thinking that they've finished the question, but actually we can rewrite root 8 as root 4 root 2, because of course 8 is 4 times 2. Now 4 is a square number, so this is really 3 times the square root of 4, which is 2, times root 2. Now that's 6 with a root 2 on the end, 6 root 2, the same answer that we got here. You can obviously see from this that finding the biggest square number is a real advantage because you get to the answer much more quickly. Now here are some questions for you to try. Press pause and have a go. When you're ready, press play. Here are the answers. In some cases, your working out stages might look different, but you should have still got to the same final answer that I have here. Now the third rule of surds that you need to know is this one here. Again, I'm going to illustrate this for you with some examples. So here, I've got root 9/16. Using this, I know that this will be root 9 over root 16. Root 9 is 3, and root 16 is 4, so the answer to this is 3/4. Now on this question, I can't do the square root of 12, and I can't do the square root of 3, but I can do 12 divided by 3. So I'm going to rewrite this using this rule as root 12 over 3. Now 12 over 3 is 4, so this is root 4, and the square root of 4 is 2, so the answer to this is 2. Now here are two for you to try. Press pause and have a go. When you're ready for the answers, press play. For C, I can see that both of these numbers are square numbers, so I can rewrite this as root 4 over root 25. Root 4 is 2, and root 25 is 5, so the answer for this one is 2/5. For this one, we don't have square numbers, but I can see that 45 will divide by 5, so I'm going to write this one as root 45 over 5. Now 45 divided by 5 is 9, so that's root 9, and root 9 is 3, so the answer for D is 3. Here are some more for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's a slightly more difficult exam-style question for you to try. Press pause and have a go at it. When you're ready, press play. Here's the answer. Now there's one more thing that you need to know, and it relates to algebra. We all know that if we've got 3x plus 2x, then that is 5x. In exactly the same way, 3 root 7 plus 2 root 7 will give us 5 root 7. Similarly, if we've got 6 root 5 minus 2 root 5, then we've got 4 root 5. In other words, the common rules of algebra apply to surds as well. Even as far as if we have 6 root 5 minus root 5, this counts as 1 root 5, so we've got an answer of 5 root 5. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. I want to simplify this surd expression. To do this, I'm going to use this rule here. Root 6 times root 12 can be written using this as root 6 times 12. Now I know that 6 times 12 is 72, so this is root 72. Now I know that to simplify this surd, I'm looking for the biggest square number that goes into it, and I can see that 36 goes into 72, so I can write this as root 36 times 2 using this again. Now that's root 36 times root 2. Root 36 is 6, and the root 2 just goes on the end. So this simplified is 6 root 2. Now, anytime you're dealing with surds, there's often more than one way to get the answer. Let me show you another way of doing this. To do this, I'm going to spot that 6 actually goes into 12, and I'm going to use that to help me. So, root 6, I'm just going to write as root 6. But for the root 12 part, I'm going to write it as root 6 root 2. Now this is root 6 root 6 root 2. And root 6 times root 6, using this, is 6. So it's 6 root 2. You can see I've got the same answer that I got here, I've just done it in a slightly different way. Here's one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Notice I've shown you 2 different ways to get there. Your working might look different again. As long as you've got 4 root 10, your answer is correct. Here's another question for you to try. A hint for this one is that when it says show that, what you need to do is ignore the answer, do this part of the question, and hope that you get the answer that matches this one here. Remember, squaring means multiplying something by itself. Press pause and have a go. When you're ready, press play. Here's the answer. Notice that to do it, I ignored the 27 and squared what they'd given me. That's here. I get this, which simplifies down to 27, which is exactly what I was looking for. Now here's another difficult exam-style question for you. The trick here is to realise that you're trying to get an answer that's a number times by root 5, and you've got a root 5 here. Remember, you can change the order of this part as much as you want. Your final answer is going to be the number that you get in front of the root 5, because it's asking you for the value of k. Press pause and have a go. When you're ready, press play. Here's the answer. To get this, I rewrote root 6 as root 2 root 3. I couldn't do anything with root 5, so I left it as it is. I know that the root of 4 is 2. Root 3 I've had to leave as it is. Root 2 I've left as it is. And root 1 is 1. Then I've rearranged this to put the root 2's together and the root 3's together. I've still got the 2 and the root 5, and of course timesing anything by 1 leaves it as it is, so that can go. Now that part gives me 2, that part gives me 3, there's a 2 here, and a root 5. This gives me 12, so it's 12 root 5, and that tells me that the value of k is 12. There's more than one way to do this, so your working out might look different, but you should still have k equals 12 as your final answer. Here's another difficult one for you to try. To do this one, you need to simplify the root 80 and simplify the root 180. The hint here is that we've got a root 5 that we're looking for, so try to use this when you're simplifying. Press pause and have a go. When you're ready, press play. Here's the answer. For this difficult-looking question, I'm going to start by doing this in the same way as I do a normal algebraic expansion. So I'm going to do 5 times 8, that's 40. 5 times minus root 3, that's minus 5 root 3. Plus root 3 times 8, that's plus 8 root 3. And plus root 3 times minus root 3, that's minus 3. Now I can simplify this. I've got 40 minus 3, so that's 37. And I've got minus 5 root 3 plus 8 root 3, so that's plus 3 root 3. You'll see that I've got this in this form now. C is equal to 37 and D is equal to 3. The most common mistakes with this type of question are here, where we've got a plus root 3 times a minus root 3. Remember to use this rule. Root 3 times root 3 is 3, and plus times minus is minus. The other mistake is forgetting to simplify this bit here. Remember, you've got minus 5 root 3 and plus 8 root 3, so those two can go together to give you 3 root 3. Here's one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here's another one for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. Here's another one for you to try. Remember that squared means that you need to multiply this by itself. So to start with, you need to write this bracket out twice. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another similar one for you to try. Don't worry about the fact that it says is an integer. Concentrate on squaring this and multiply it all out. You should find that you get a whole number as your answer. Press pause and have a go. When you're ready, press play. Here's the answer. These are the rules for surds that we've learnt so far. We're now going to look at the last technique that you need to be able to do with surds. This is where we're asked to rationalise the denominator and simplify. This part means that you need to get the square root out of the denominator. To do this, what we do is we multiply by root 7 over root 7. Remember that root 7 over root 7 would just be 1. We're multiplying by 1, so we're not going to change the value of the number at all. So we've got 35 times root 7 on the top, that's 35 root 7, and root 7 times root 7 on the bottom, that's root 7 root 7. Now using this, we know that root 7 is 7. So on the top we've still got 35 root 7, but on the bottom we've just got 7. Now 35 divides by 7 and we get 5, and then we've still got the root 7. The denominator of this is now rationalised, and I've simplified it as well. I want to go through these for you now. For this one, we multiply by root 3 over root 3. So on the top that gives us 6 root 3, and on the bottom root 3 times root 3 is 3. Now 6 divided by 3 is 2, so that's 2 root 3. Here I multiply by root 5 over root 5. I get 5 root 5 on the top and 5 on the bottom. Now 5 divided by 5 is 1, so this is 1 root 5, which I just write as root 5. For C, I multiply by root 7 over root 7. I get 2 root 7 over 7. 2 won't divide by 7, so I just leave this one like this. For this one, I multiply by root 8 over root 8. So on the top, I've got 3 root 2 root 8, 2 8s are 16, so that's root 16. And on the bottom, I've got 8. Now, 16 is a square number, so root 16 is 4. So I've got 3 times 4 on the top here, that's 12, and I've got 8 on the bottom. This will simplify to 3 over 2. Here are some for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Now here are 2 more difficult exam-style questions. In this one here, I can see that I want my answer to be in this form with a root 2 in it. That's telling me I've got to rationalise the denominator for this part and get this part into the form where I've got a root 2. So I start with this part. I've got 8 over root 2, and to rationalise the denominator, I multiply that by root 2 over root 2. I want to add on this part. Now I can see that 36 goes into 72, so I'm going to rewrite this as root 36 root 2. Now, this part here gives me 8 root 2 over 2, and this gives me 6 root 2. Now, 8 divided by 2 is 4, so that's 4 root 2 plus 6 root 2, which equals 10 root 2. For this second part, you need to notice that when you expand this on the top, you'll get the difference of 2 squares. So 5 squared is 25, and root 3 squared is 3, and it's a difference, so that's minus 3. This is over 3 root 22. To rationalise, I need to multiply by root 22 over root 22. So on the top here, I've got 22 root 22, and on the bottom, I've got 3 times 22. Now I can cancel out this 22 and this 22 to give me root 22 over 3. Here are some similar questions for you to try. Press pause and have a go. When you're ready for the answers, press play. Here are the answers. Here's another question for you to try. A tip for this one is to just work on this part here. The answer you should eventually get will come out to be this as long as your working out is correct. Press pause and have a go. When you're ready, press play. Here's the answer. Here's another question for you to try. Press pause and have a go. When you're ready for the answer, press play. Here's the answer. We're now going to look at more difficult questions, where, to rationalise the denominator, we need to use a special technique. The technique we're going to use relies on knowing about the difference of 2 squares, which we've come across before. If I was to multiply this out here, I'm going to get x squared. The plus 2x and the minus 2x go, and I've got plus 2 times minus 2, so that's minus 4. You need to be able to do this sort of thing instantly. So for this one, it's going to be x squared minus 36. And for this one with surds, it's going to be 5 times 5, which is 25, minus root 3 times root 3, which is 3. And 25 minus 3 is 22. Here are some of those for you to practice. Press pause and have a go. When you're ready, press play. Here are the answers. It's important to notice how when we multiply something like this by something like this, it gets rid of the surds and ends up as just a normal number. Getting rid of the surds is what rationalising the denominator is all about, so that's why this technique is useful. Notice again here, a surd, but in our final answer, there are no surds. So when we see a question set up like this, what we're going to do is multiply the whole thing by this, but with a minus instead of a plus, or a plus instead of a minus. So we've got 3 minus root 2. We have to multiply the top by this as well, so that effectively we're multiplying by 1. So multiplying the top gives us 21 brackets 3 minus root 2. And on the bottom, we've got the technique that we practiced earlier. We've got 3 times 3, that's 9. And we've got plus root 2 times minus root 2, which is going to be minus 2. Remember, the plus root 2 times 3 and the minus root 2 times 3 disappear. So we've now got 21 brackets 3 minus root 2, and that's over 9 minus 2, which is 7. At this stage now, you should spot that you've got 21 and 7. We can cancel this down, so we get 3 brackets 3 minus root 2. You can leave your answer here, or it's also acceptable to multiply out the bracket to give 9 minus 3 root 2. Either of these two are correct. Here are two for you to try now. Press pause and have a go at them. When you're ready for the answers, press play. Here are the answers. Now in this question, I'm asked to show that this can be written as this. If we look at this here, we can see there's a denominator, but it's rational. The denominator here is irrational, so what we're going to do is rationalise the denominator. So we've got 1 plus root 3 over 6 plus root 27. So I'm going to multiply that by 6 minus root 27 over 6 minus root 27. I'm going to leave the top in brackets for now, so I've got 1 plus root 3 and I've got 6 minus root 27. On the bottom, I'm going to use my normal technique. 6 sixes are 36, and we've got minus 27. Now I can start multiplying out the top. So I've got 6 minus root 27 plus 6 root 3 minus root 81. This is over 36 minus 27, which is 9. I'm going to start simplifying this. So I've got 6 minus root 27 can be written as root 9 root 3. I've got plus 6 root 3. And root 81 is actually 9. And this is over 9. Now I've got 6 minus 9, so that's minus 3. I've got minus root 9 root 3. Well, root 9 is 3, so that's minus 3 root 3. Plus 6 root 3. And that's over 9. I've got minus 3 root 3 plus 6 root 3 is plus 3 root 3 over 9. And now I can divide by a factor of 3. So I've got minus 1 plus root 3 over 3. I'm going to glance up here, and yes, this matches what I've got. Because I've shown all my working, I have shown that this can be written as this. Here are two of those for you to try. Press pause and have a go. When you're ready, press play. Here's the answer for number 1. And here's the answer for number 2.